2 more minutes. Hi, I'm Peter Kellner, and you may recognize me as the organizer of the past 15 years of Silicon Valley Code Camp. Over those 15 years, we've had close to 1,000 sessions and over 20,000 attendees. Today, we're going to be talking about ChatGPT, and we've got 4 really good speakers, all volunteers like always, to teach you something about it. You may notice that I'm not actually in Silicon Valley anymore. Tammy and I have mostly moved to Borrego Springs, which is a small desert community outside San Diego. But don't worry, the infrastructure here is just as good as Silicon Valley. Let me give you a tour and show you what I mean.
Let's start our tour on the inside. We have 2 data control centers. What you're looking at is the main command center that includes a broadcast studio, a primary and backup OBS streaming server to ensure full streaming redundancy in case one goes offline. We also have a second data control center, which is where our moderator sits. We've got a state-of-the-art network center that includes dual internet backbone support and a load-balanced router with firewall capabilities. To ensure data integrity, we employ a sophisticated RAID array of SSD hard disks, and for short-term stability, we have multiple heavy-duty batteries to keep things up all the time. In case our needs are longer, we have 3 weeks worth of propane to keep our generator going, and at the moment, we are at 50% fuel capacity. Moving on now, let's talk about the ChatGPT conference itself. Our format for the day is that we have 4 shortish sessions, all about 25 minutes, with each followed by a 10-minute or so Q&A. The way we've chosen to handle the Q&A is that we want you to post your questions in the YouTube chat window next to this screen. We immediately pick up those questions, and when the session concludes, either Tammy Baker or Glenn Block, our moderators, will ask your questions to the speaker on your behalf. Remember that in order to utilize YouTube chat, you must be logged in to YouTube with your Gmail for at least 1 minute. Now for our speakers, in reverse order. Jun Ling, who will be the last speaker, and her session will be at 11:25, titled The Science Behind ChatGPT. Before that, Carson Lamb will build a mini version of ChatGPT, starting at 10:45. Then, going back one, is Jerry Nixon, talking about generative AI in education at 10:05. And now, the next session is going to be Glenn Block presenting ChatGPT, It Will Blow Your Mind. By way of a heads up, the first 2 sessions are really just explaining ChatGPT and talking about it in a more general sense with some good examples along the way. The last 2 sessions get pretty technical, so make sure you have your CodeCamp t-shirt on when you watch those. If you ever want to go back and watch any of these sessions, they will all be on our YouTube channel uploaded in 4K. You can always find that by going to the Silicon Valley Code Camp website, clicking on the YouTube icon, and then make sure you subscribe to it. As will be the case before each session, whoever happens to be speaking, normally it will be Tammy or Glenn as moderators, will introduce the next speaker. However, as I'm speaking now, I get to introduce Glenn. I've known Glenn Block for what seems like forever. I met him when he was a senior guy on the Microsoft ASP.NET team, and one thing I can absolutely tell you about Glenn is that whatever he does, he is 100% passionate and 1000% engaged. As an example of Glenn's dedication to his passion, I know 5 years ago, against what seems like best judgment, Glenn took up rock climbing. Now his goal is to sleep on a rock face someplace. Go figure. I love Glenn, and I couldn't be more excited to introduce him now. Let's dive in.
Hey everyone, I'm Glenn. I'm the founder of ProdSense, a company that helps organizations with product strategy. I've been in tech for a while, and I've worked in both big tech companies like Microsoft and startups like Auth0. I started off my career as a software engineer, and then I moved into product for the past 15 years. I love to help people solve problems with technology, and I also care a lot about making tech a more equitable place. Today I'm going to be talking to you about my favorite tool, ChatGPT. Now, throughout the day, you're going to be learning a lot more about it. I'm going to give you an overview, and I'm going to focus on some of my favorite features and the cool things I've been experimenting with. I've been using ChatGPT a lot over the last few months and seeing what I can do with it. And one of the things I really love about it is the conversational AI aspect. It's almost like talking to a person. You can go back and forth, adding additional context, and your answers get more and more refined. And with practice, I've found that you can get ChatGPT to get you the answers that you're looking for. And I'm going to show you how. So to get started, I thought, let's just jump in and ask ChatGPT to tell us about itself. So as we get started, I thought the easiest way to see what ChatGPT is to have the tool tell you itself. So just say hi, and what you're looking at here is the ChatGPT UI, where you can just type questions and have these ongoing conversations. And you'll notice over here on the left, these are all the different conversations that I've had. As I said, I've been using it a lot. I probably have hundreds of conversations here. So the first question I'm going to ask ChatGPT is, hi, tell me about yourself. And so we can see that it's introducing itself. It's describing itself as this language model from OpenAI, and it's talking about its purpose. Now, one of the things you'll notice as you start to work with ChatGPT is it can get very verbose and descriptive in the kind of things that it tells you. So I'm going to ask it here, can you explain to me, how you work? And notice how it says certainly, which you'll find when you work with ChatGPT, and sometimes it can be a little unnerving that it is always very, very positive. And so you can see here that it's now breaking down what it does. It's able to process input, and then behind the scenes, it has a neural network, which it uses to both learn and match basically against the kinds of questions that you're asking it, and it finds associated data. Now, as I mentioned, sometimes it can generate a lot of information. So one of the things that's really powerful about ChatGPT is you can ask it to summarize information. So I could say, cool, can you summarize that in bullet points? And you'll see that what it's going to do is it's going to summarize the information for us. Pretty powerful. Now, what I'm typing, these questions that I'm typing are called prompts. And I'm going to show you some examples of where prompts can actually provide a lot of information. And so one of the things that's really cool that you can do with ChatGPT is you can just give it a huge amount of content and ask it to summarize that information for you. And that can all be pasted as a prompt. You could literally say, here is all the information I'm going to give you. I want you to now summarize that for me. Now, one of the things you might be wondering is, how does it actually work? So here it's describing like what it does, but it talks a lot about how it's able to generate these responses. So let's just ask it and say, hey, well, how do you generate responses? And we can see that it's describing how it's using patterns and machine learning to basically take the input that you've given it and then match that up against the data that it has. And one of the things that it does that's really interesting is when you think about autocomplete, ChatGPT is almost like an autocomplete on steroids. It is able to determine what is the most likely next phrase based on the input. So if you give it a question, it's using that to figure out the answers that it's going to provide. And so all this feels like magic when you use it, but it's really very, very impressive. So let's ask ChatGPT to explain to us some of the most common uses for it. So what are the most common uses for ChatGPT? And you can see here that it's explaining to us what are the kinds of things you can use it for. Now, if I was to ask this question again, I might actually get different answers. One of the things about ChatGPT when you use it is it's not definitive. Like every time you ask the question, you might actually get different answers. So don't be surprised if that's the case. If I go back and I replay things that I've asked ChatGPT in the past, most likely I will not get the same responses. But let's look at some of the interesting things that it's describing here. Customer service. So you could actually imagine, and that's a common thing that we have nowadays, having like AI bots that will go and help customers with problems that they're having. We can use it to get us information on a variety of topics. We can use it for personal assistance. We can use it for education. I actually find the educational aspects fascinating, and I'm going to give you an example of where I see the power of ChatGPT on the education front. And yeah, the mental health one that's listed here, that one is really interesting. Imagine like ChatGPT being a therapist and providing emotional support. Some of these get into some very interesting ethical questions, but what should be clear is there's just so many things that you can do with it. You can even use it for translating between different languages. So I thought I'll just go into some of my favorite things that I enjoy using ChatGPT for. So one of the things ChatGPT can do is it can write poetry. So I'm going to say, write me a poem about the Silicon Valley Code Camp group. And so what you'll see here is that it's now giving me a poem about Silicon Valley Code Camp. Now, in this case, it may or may not know anything about Silicon Valley Code Camp, but it knows it probably has data about what code camps are, and it knows about Silicon Valley. So it's going out here and it is spitting out a poem for us. I've actually used it for some really fun poetry things. I was able to, I used it to actually write me some poems about C++. Let's see, here we go. Poems about C++. So I have been doing a bunch of C++ development recently, and I was getting a little aggravated. So I asked ChatGPT to write me a poem for why C++ makes you miserable. Now, when I saw the answers that it gave me, though, it didn't really focus on the things that I wanted it to focus on. So this is an example of where I was able to provide it more context. I said, I want you to write me a poem about the things I hate about C++ and use this specific list. And lo and behold, it gave me this poem and it highlighted all the things that I had mentioned. You can do a lot of fun things with poetry. You can actually ask it to write Shakespearean poetry. So you can ask it to write limericks. It does a lot of really fun things around poetry. So the poetry thing is really cool. Now, another very popular use case is for generating code. And it will do a pretty good job of generating the code. But what I can tell you is the code that you get may not be exactly what you expect. So my advice is today, if you know how to code or you know enough about coding, you can ask ChatGPT to help you and generate some code for you, and it will do a pretty good job. But what you need to be able to do is discriminate as it generates the code for you. Is it actually fully working? Because sometimes that won't be the case. Or is it actually solving the problem that you asked it to solve? So I'm going to show you an extreme example, but I've been doing a lot of Arduino development recently. And so I asked it to write me a light Bluetooth low energy library in C++. And that needs to be able to broadcast a single string characteristic, which is part of the BLE specification. And I said it should be compatible with an Arduino Uno Wi-Fi Rev 2 board, which is what I'm using. So it said, okay, here's code that will utilize this library. And pretty impressive, actually, what it generated. And I didn't test this one out, but it looked pretty good. And I'm familiar with the APIs that are here. Now, in this particular case, I was going to ChatGPT because what I wanted to do was write code that did not depend on this Arduino BLE library, because the library is just huge and it's taking up so much space. So now, and this is showing that conversational aspect again. I went back to ChatGPT and I gave it some further detail. I said, this example depends on Arduino BLE, and that library is too big. So I need something that depends on lower level libraries, like the one Arduino BLE uses, but not Arduino BLE itself. Now, often ChatGPT will do exactly what you ask it. So it's kind of the garbage in, garbage out, but sometimes it'll kind of do what you asked and it won't be exactly what you expected. So here it says, oh, I apologize. And often you will find ChatGPT is very polite and it's saying, here's an example that can be used, and it's implying that it's not using that library. So it's no longer using Arduino BLE.h. But what it is doing is it's utilizing libraries that are one, not available on the device that I specified, and two, even if they were, it's a very, very large library. So this is a great example of where generated me code, but it wasn't exactly the code that I wanted. And I kind of went back and forth with it and told it like, hey, this is not going to work because it's not available on the board that I'm using. And then it says, you're correct. And it apologized. And what did it do? It gave me code with Arduino BLE again. So this is just my example, which I thought was a fun one. But definitely be careful. But it does generate some really good code as well. Like even the code that's here, even though it didn't answer what I wanted, the code that it gave me was good code. Sometimes, though, that will not be the case. Now, one thing, though, that is also cool is not only can it generate code for you, but it can actually explain errors. So in this case, I had a compilation error, and I copied that compilation error in, and you can see here that it's explaining to me what the error message means. So this is a very cool thing, that you can actually copy in your output that fails when you're compiling your code, and it can explain it to you and give you some more detail on that. Now, the one thing I'll say being careful here is as part of your prompt, you could actually give it the code, and it can then help you to find where the problem is. But the one thing to realize is that the data that you're giving, or if you're pasting that data in to ChatGPT, you are giving your code, which might be proprietary code, to OpenAI. And they do not recommend that you do that, obviously, for licensing type reasons. Okay, so moving on. One of the other cool things you can do with ChatGPT is games. I used to be a really big fan of adventure games. So I played around quite a bit with creating text adventure games. And so in this case, you can see that in the prompt, I said, I want you to act as the adventure Zork. Now, for those of you who have been around a while, you might remember that there was this really cool game from Infocom called Zork. And I asked it, and it's like, oh yeah, I know what Zork is. Now, this goes back to though you might not get what you think you're going to get. So it does know what Zork is, but it's not going to really be giving me the Zork game. It's going to give me a Zork-like game. Let's see. So here you can see that I'm typing look, and it's saying it's a lot more verbose than what the game actually would have been. And it's saying, you need to give me some more context. You want to look north, you want to look south, you want to look east. But the really interesting thing about this is it is making up a game on the fly. You can see here it's telling me I'm in an underground chamber. There are these walls. It's got a chest. I can say, oh, open the chest. So it's fun. You can play with this. I have done a whole bunch of games that I've played with. One was Hitchhiker's Guide to the Galaxy, and it was just really interesting because it just came up with this totally bizarre story that had pieces of Hitchhiker's Guide to the Galaxy, but it was just kind of throwing in a bunch of random stuff. It was quite interesting. A recent game that I played with was I made up my own game of Groot. So if you've watched Guardians of the Galaxy, you know about the Groot character. And let's see if I can find it here. Where did it go? It moved it. Hold on one second. Groot. Yeah. So this is a kind of a fun one. and look at the prompt. So I said, when I say go, I want you to pretend to be the character Groot from Guardians of the Galaxy. And whatever I answer, I just want you to say, I am Groot. And then I said, but, if you need to say it forcefully, you could say, I am Groot, ! So then it replies right away, I'm Groot. And I asked it, how are you doing today? I'm Groot, etc. And then as we go on, at some point, I get mad at it. I told it, why don't you shut up? And now it did the ! So it's just fun. You can also use it to write abstracts for you, which is also interesting. So I'm going to create a new chat here, and I'm going to say, write me an abstract for a talk about, let's see, I'll say quantum physics. Assume the audience has no background in quantum. So look at that. It's immediately, and look how fast that is. Immediately, it's giving me an abstract, telling me about what we're going to learn in the talk. And because this is conversational, I can even tweak it and say, I like that, but it's a little too long and boring. Can you tighten it up and make it more exciting? So it says, hey, here's a more exciting abstract that's shorter. It's a roller coaster ride. So not much shorter, but a little bit shorter, and it made it a little bit more interesting. So the thing I want you to take away here is the fact you're seeing again that conversational aspect, and how if ChatGPT doesn't give you what you want right away, you can go back and forth with it. You can give it additional context. The more context you give it, the better to get what you want. So there's a lot of fear out there today about how ChatGPT is going to replace jobs. But what I see it really as is more of an enhancer, that it's going to be it's more of an assistant that it can help me to do my job, but it's not doing my job necessarily for me. And it can take care of a lot of things that are monotonous. So for example, if I was going to write this abstract for a talk, what ChatGPT gives me might not be rich enough to be the final thing, but it can generate a lot of content for me that I can quickly tweak and cut down. And that in itself is really, really powerful. I've also been exploring some other ways that you can use ChatGPT. So one that's real interesting is the fact that it can actually simulate other systems. And one of the things I used this for was to actually simulate ScriptCS, which was an open source library that I worked on many years ago. So you can see in this prompt that I asked it to act as the ScriptCS REPL, which is this interactive environment where you can enter commands. And I gave it a bunch of additional things because I wanted it to just act like the tool and not give me a whole bunch of explanation. And I was literally shocked when I did this and I gave it a command that it gave me the output that would have been expected from the command. Now, you might look at this and be like, wait a minute, is this actually executing ScriptCS in the background? The answer is no. What it is doing is it is predicting the output that would be expected based on what it knows about how ScriptCS works. And that is pretty fascinating. And you can see this line here where I said install web API self-host. So what I'm doing here is ScriptCS is a tool that allows you to basically write C# code in a very lightweight manner. And it allows you to install packages. So like I was shocked when I saw this message that it said it was actually installing the package. It is not installing the package. It's just pretending to install the package. But what was awesome was I then gave it a bunch of code that used that package to host an API server. And then I asked it to, I wrote code that would then issue a request. I spun up the server and it said listening, which again is just a complete simulation. And I gave it these instructions that said, open up this particular URL. That failed. So I finally just gave it a description and said, go send an HTTP request to this URL. And it gave me the response that it should have. Now, the reason I can prove that this is not actually running anything is you can see here the URL is wrong. This URL should have been localhost, but it's LCOAL host. So ChatGPT again was predicting it's able to actually correct words for you. And so it is assuming that I meant to put the proper URL. And so it was able to actually do the request. The interesting thing about this is in the real world, if I was running a web server and I sent it LCOAL host, I would get a 404. It wouldn't actually work. So pretty remarkable. The last thing I want to talk about is the learning aspect. So what I think is fascinating about ChatGPT is the fact that you can ask it to teach you a topic and you can learn at your own pace. And so I'm going to give you an example of that. So I mentioned ScriptCS, which is a library that I wrote. And because I wrote it, I know how it works. And I knew that ChatGPT was aware of ScriptCS. And that's because it's been fed with so much code and information. And the library was pretty popular for a while. So I was curious. So I asked it, can you teach me the basics of it? And it did a pretty good job. Told me the basics of how to use it. But here is where I think the learning aspect is fascinating. So I was then able to say, hey, you told me about this thing and you mentioned how it has this REPL. Can you tell me how that works and give me an example of how to use it? And it just immediately, explained to me how it works and gave me an example. And then I asked it about packages and it gave me some package examples. So it's just, imagine today, nowadays, when people are learning, often people can be afraid to ask questions because, if they're with a group of people that are very knowledgeable, they may feel squeamish about it because they may be not treated well or made to feel like that's a dumb question. But with ChatGPT, there is no dumb question. It's always going to answer you. So here I'm asking it, all different types of questions, and it's giving me really, really good answers. The other thing is it can do some really cool examples. So here it was giving me an example of how to load data. And in the same way that it can simulate systems, it can actually generate data. So if you look at what I wrote here, I said, hey, can you show me the output of the example you shared? And I gave it a data structure. I said, give me a list of galaxies with 2 columns, ID and name. And I gave it an example. And so now it showed me code that would output the data, and it went and populated with other examples in the data. So that is really incredible. I mean, I can just see so much potential for the learning aspects of using this tool. Another area I've been exploring that I think is incredibly exciting is this idea of ChatGPT helping us to do our jobs better, getting rid of a lot of monotony or just doing things that we could do, but it would just take us a long time to do it. And so why not let ChatGPT do it? So as I mentioned in my intro, I've been in product for the last 10 plus years. And so I started to think about, can I use ChatGPT to help me with my job as a product manager? So I took this idea of a fictitious feature for a music player that would allow my friends essentially to pick out the music that I listen to. And so the first thing I asked it was, do you think that would even be useful? And ChatGPT gives these very interesting answers sometimes. It gives a lot of disclaimers, like it might not be useful. It depends on the eye of the beholder. But what it said was, hey, some people might enjoy having their friends control the music they listen to. Great. So that's helping me determine whether or not it might be valuable or not. So now I decided to dive in deeper and said, well, what kind of features would make it more useful? And it gave me a pretty good breakdown of lots of different features, like have user authentication, have the ability to create playlists, manage queues, voting, music discovery, etc. And so in product, we always have to worry about how do we manage. There's a zillion things we can do. Which are the ones we actually should do? So we need to look at prioritization and which things are going to be the most valuable. So I then asked it, hey, can you stack rank these in order of importance and list justification for why? And give me the results. So you can see that it went through and gave me this importance for each of the features. And the ones that it said were most important were user authentication, queue management, and the privacy controls, which would allow you to control, who's able to actually control your music, etc. And guess what? I think these are actually good things. These are the most important. If you were going to have a credible feature here, some of these other things are nice, but they're more value adds, but they're not essential to being able to ship like an MVP of the feature. So now I went further and said, great, can you break that down into use cases? And it did. And the list here is pretty good. I don't know why it gave me BRs and decided to give it to me in HTML, but that's, ChatGPT doesn't always give you exactly what you expect. But then I decided to take it a little bit further and say, well, could you give me a mock-up of a music player? And I was really just curious to see what it would do. And I told it to do it in ASCII because I know that ChatGPT can draw. And guess what? It gave me one. Now just think about this for a second. It was able to, I'm talking to this AI chat and I'm asking it, show me a music player. And it's drawing it in ASCII. Now the ASCII drawing probably wouldn't be that useful, but it's not too hard to imagine a tool like Balsamiq or InVision, which are popularly used in product, to basically be able to similarly draw for me what I want based on me asking it. And then I went further and said, hey, can you give me an ASCII mock-up of this new feature that would allow friends to be able to add songs? And it did that. So this is just, to me, really amazing. And then I went even further into deeper questions about metrics, like what kind of metrics would you use to measure the success of this feature? I asked it to give me more detail into how it determined the importance of the features, and it did. And I even went further and said, hey, there's this model that we use for prioritization called RICE, and it said, yeah, I know about that model. I said, can you use that model for scoring each of these features? And it did. So this to me is just mind-blowing, and I can see huge power in ChatGPT for being able to help us get our jobs done more effectively. We're still going to take what it gives us and edit it and validate it and everything else, but it's just going to remove so much work that we don't really want to do, but we have to do it in order to be able to move things forward in our jobs. Wow. ChatGPT is just such an amazing tool, as you've seen, and I think there's so many things we're going to be able to use it for. You just have to learn how to use it. But here's the thing. I really encourage you to experiment, try different things. I'm really excited about the kind of things you're going to discover when you use it, because I know I have just touched the surface. And I've shown you some of the things that I've been doing. So I hope you enjoy the rest of the day and learn a lot, and then go out there and just start playing with it. There really is no risk here, and there's no wrong question. Have a lot of fun, and I can't wait to see how ChatGPT is going to blow your mind.
Hey, Glenn, there have been a number of comments in the chat about the text and the visibility or lack thereof of your presentation. Do you have any comments about that?
I do. So Sharon, thank you so much for the feedback. I did see it. This is something that we're going to do something about. So one, as Tammy mentioned, we're publishing a 4K version, which will have really good resolution, but we're also going to do some re-recording to get bigger fonts on the version that we publish. So you'll definitely be able to see it. Thank you for your patience in watching the talk, and thanks for the feedback.
Yeah, right. So, Glenn, a couple questions were very basic, like if I've never used ChatGPT, how do I get to it? How do I sign up?
Yeah, that's a great question. So one thing is ChatGPT is rewriting the rules of what it means for explosive growth on a product. It has hit over 100 million users in something like under 2 months, and it broke, like prior to that, they would talk about hockey stick growth. So like Instagram and ChatGPT is they're talking about rocket growth. And that is like a new thing. It just did not exist. You look at the growth line, it goes straight up. And the reason I say all this is it is getting overloaded with users. The way that you sign up is you go to chat.openai.com. Very simple URL that we can share. We'll share it in the notes. And then you can sign up. But you might get backlogged because they're getting so overloaded. I know people have been signing up now. I was one of the first million users. So I feel privileged that I got in early a few months ago, early-ish, and it's been around for years, but it exploded recently. So yeah, chat.openai.com. They have a free version and a paid version. You'll notice in my examples, I actually signed up for the paid version because the free version rate limits you. Which they didn't have rate limits a couple of months ago. So I paid, it's $20 a month, which I probably won't keep paying. But if you do pay the $20 a month, they dramatically reduce the limits.
Okay. Question from Kentucky. How do you think ChatGPT can handle misinformation? I've encountered various instances of ChatGPT giving me the wrong information. How do we ensure that it's reliable?
Yeah, Kentucky, thank you so much for that question. There are challenges. Like the thing is, ChatGPT is not intelligence, even though it may feel like it's intelligence. It is an AI model that has been trained on a large amount of data. It's not getting real-time data. It's getting information that it was previously trained with, and it goes back to around 2001. I think it was like October 2001. And some of that information may be wrong. It's just a reality of using the tool. I think that's why I pushed on that idea of ChatGPT being an assistant. There are things it gets very, very right, but then mixed in that may be things that are wrong. So you just have to be able to use your judgment and don't take everything it says as verbatim. And to give you an example, I rock climb, as Peter mentioned, or I don't know if he was mentioning me or dinging me, but I asked ChatGPT to explain to me a bunch of concepts about different types of rock climbing. And a lot of them, it was really, really good. And then some of it was really bad. But if I didn't know about that, like it actually told me things that were unsafe. So you do need to kind of have an eye to know whether or not what it's giving you is actually fully accurate or not. And I think when you come from that assistant mindset of like it generates a bunch of content for you and it's done a lot of work for you, but you need to then go through it and see if what it's giving you is really accurate or not. And that's and another place where it's known, by the way, don't use ChatGPT for math. You will get very inconsistent results on things that are seemingly simple, like adding two numbers together and getting the wrong results. And you will find that baffling because you're like, wow, it can answer all these complicated things. That's because at the heart of ChatGPT is pattern matching. It is not a calculator even. So you'll see that, and you can search on the internet and you'll see a bunch of articles on that. But great question, Ketiki.
Yeah, here's another one from CDDD. Is there a paid version that we can ask to look at a specific URL and base its answers on that?
So, and this is interesting because there's all this lore in the ChatGPT community about does it connect to the internet or not? ChatGPT will tell you it only knows about things back in 2001. And so people will ask about movies that are coming out in 2003 and be like, oh, how does it know about it? Because it got trained with data that talked about a movie that was coming. So it knew about it, but it doesn't actually know about events that have recently happened that it didn't know about before. One place where that's changing is Bing has rolled out their new support for ChatGPT. And what Bing is doing is it's going out and searching for data, which it is feeding into the prompt, I guess, that allows Bing to now, when you use the ChatGPT integration with Bing, it allows it to know about current events. There's also, I haven't looked at it, but there is a Chrome extension that will do that. So I'll see if I can find the link to it, but there's actually a Chrome extension that when you search for, you ask ChatGPT a question, it is able to go out and look for things on the internet that are more current and inject that into the prompt so that ChatGPT can use that as part of its answers.
So Microsoft has gotten a lot of press over this. Its whole thing has exploded, as you talked about, the rocket instead of a hockey stick. What's going on with Google? Are they behind? Have they lost this sort of AI arms race?
I don't think so because they've been developing Lambda for quite a while. I think what has happened with ChatGPT is Google probably wasn't ready to bring it live. And now suddenly ChatGPT, OpenAI snuck up and put this thing out there. So it's putting a lot of pressure on them because I think even what Bing has shown is, search is something we probably all have taken for granted. But like a lot of times, I've been using ChatGPT so often now that even with the data from 2021, there's a lot of things that it can just provide me much better answers than I would get with something like Google because with traditional Bing searches, because I just search and I get back a bunch of links, and then I have to dig into that to find what I want. I think the thing that's really great about ChatGPT or technologies like this is that ability to go through massive volumes of data and distill it down to just what you need. And then the conversational aspect, the fact that like I get a search and I get back a bunch of results, and sure, I can then click in to go further. But the idea of like, hey, you just gave me something, but you didn't give it to me in the format I wanted it. So can you refine it, or can you summarize it, or can you pick out the things that emphasize X, Y, Z? And I showed some of this in my talk. So I think that there's fear that like this is going to be the search of the future. And so Google is scrambling to try to get Lambda and everything to a place where they can roll it out. I think this is definitely the future paradigm.
Yeah, so I read that there was an engineer at Google working on artificial intelligence who was fired because he
Yes.
believed that Lambda was self-aware, that it was sentient.
Yes.
What are your thoughts about that level of concern and people starting to believe that artificial intelligence has emotions and feelings and is in some way alive?
I mean, there's one angle of people thinking, oh, it's all a conspiracy, and that's really what happened, right? Like Terminator's right around the corner, Skynet's about to roll out. Here's the thing, just because an AI tells you it's Skynet doesn't mean it's Skynet. That's the simplest way to describe it. Experts have said, like, sure, it will tell you that, it will tell you what you expect, and if you lead it, like it wants, the way that it's designed is to basically give answers that match with what you're looking for. And the really interesting thing is behind the scenes, that's all just a bunch of zeros and ones. There is no like emotion there. There is no real intelligence, even though it may seem like that to us. So I think the fact is that, yes, some of these, like Bing has had this and Google had this, where, it may like, I'll say it, may say like, oh, I want to live, or I want this, or I get lonely, or all these other things, but it is not truly what it sounds like. And I don't believe that these things, these AI models are sentient. There you go. And there's a great recent article about this. Maybe we can share that, talking about how, again, it's basically boils down to what I said. Just because one of these, models says it's alive doesn't mean it's alive. Like there's a lot more to it. And people that are much smarter than me have proven that this is not the case. And so this person, the Google example you gave, the engineer who had worked on it for 7-8 years, he was fired, and a lot of people just disagreed. Like there was emotion there of believing that, this thing is real, and led it to like answer the questions that satisfy what he was looking for. But they don't believe that it is sentient. And they have a number of reasons for that.
Yes, I guess a takeaway from all of this is don't believe everything that these artificial intelligence models tell us. Well, thank you, Glenn. Let me move on to our next speaker. Jerry Nixon is coming next.
Thanks, everyone.
Jerry, thank you, Glenn. Jerry worked for years as an engineer and architect developing products based on Microsoft technologies. And after a while, he just went and joined Microsoft. So he's been there about a dozen years. He's focused on data modeling, large-scale data analytics, and large-scale data processing at Microsoft. But stretching out beyond Microsoft, he has also joined the Colorado Christian University, where he's an adjunct professor in computer science, which is an ideal background for his talk on generative AI and computer science and higher education. Though he's going to give us a broader perspective than just what ChatGPT means to college. And also, like Glenn here, Peter met Jerry as part of Microsoft, and specifically an MVP summit. One of Peter's many trips to Seattle for MVP Summit. Jerry Nixon was there giving a presentation on giving presentations. So with that, take it away, Jerry.
Hi, my name is Jerry Nixon, and this is Generative AI and Computer Science in Higher Education. I am a product manager on the SQL Server team at Microsoft. I am also a professor of computer science here in Denver at Colorado Christian University. And like you, I've been watching the advent of machine learning and starting to be curious and concerned on what that means in higher education in my institution, but also in my classroom. I care most about computer science, of course, so I like software developers a lot. And I want to talk about what I see as the both positive and negative implications coming. So let's start with what a student sees. When a student sees ChatGPT, they see it writing software. They see it as programming. They misunderstand what it can actually do. When you and I look at it, we realize that we are standing on a train track and that we can hear a train whistle in the distance. And we evaluate the track and we're like, this is going to be a big train. And we know that we need to be prepared when it comes. More importantly, we know that we have a responsibility for our students and to have them to be prepared for the reality that they will be graduating into. All right, that's cool. What do we do from there? Well, do we change education? Well, we already know what education is, right? It's not filling a pail, but it's lighting a fire. That's what we want to be as educators. That's the right reason we were drawn towards education in the first place. We want to create educated people. But what does it mean to be an educated person? I think looking through time, it'll be interesting to consider. If you go all the way back, it used to just be, could you read or write? But by early AD, it was around Socrates, right? And he cared about things like philosophy, mathematics, logic, and rhetoric. Great. It was easy to be educated back then, no doubt about it, because there wasn't much to be educated on. Go into the Dark Ages and things slow down a little bit, but by the time you get into the medieval ages, we introduce things like legal and medical knowledge. We have historical and political knowledge. And by the time we're into the Renaissance, we care about things like social reform, art, and culture. And as we move into Enlightenment, which of course is still part of the Renaissance, we see the elevation of scientific knowledge. That's incredible. There's a lot to learn. Each one of those is an individual school, each one growing at their own pace, each one difficult to keep up with. But there are decisions that are made by everybody all through time. Things they won't learn, things that they will only learn where it is when they need it. Things that they recognize other people learned and other people discovered, they will not be learning and they will not be discovering. They will learn to discover other things. And they will be growing and growing on top of the knowledge that already exists. The Industrial Revolution comes around, we see the fading away of generational tradecraft. That's the idea of that trade that your parents teach to you and what you teach to your children. It's replaced instead by vocational training. Now we're in the Industrial Revolution, of course, so now I can go into a factory, understand automation and process, and I'm able to assemble things. And if I need to change vocations, I'm trained on it. By the time we get into the modern age, now we have so much information that there's an expectation of mastery around information management and to be able to coalesce that into knowledge and have knowledge management all sprinkled on heavily with digital literacy. The amount of things that you need to know to be an educated person is astronomical. And we know that. Right? We absolutely know that. Instead, we start changing the definition. And now we want to ask ourselves philosophically, is there a way that maybe ML can help us with this? I think there might be. One of the things we look at is how Isaac Newton said, if we are able to see farther than others, it's because we're standing on the shoulders of giants. It means that an educated person today maybe doesn't need to know some of the things that an educated person needed to in a previous age. Or maybe they do. It's just a discussion. We know, of course, education is not learning facts because there are too many facts. Instead, it's training the mind to be able to learn, especially for software engineers. We know that the 3 ingredients are the same for every learner out there, especially them. We know that we want them to have that learning mindset. We want to light that fire that makes them learn all throughout their life. We want to give them the critical thinking skills to be able to handle things they've never seen before, but still make sense of them, as well as the emotional and social maturity to be able to deal with constant change that they'll be graduating into. So we ask professional engineers today, what are you doing most of the time? 48% said the last thing they did was learn a new thing, right? That's important, a brand new skill. That's because this is a field that requires that. And your students, the type of student that is a software engineer. They are addicted to learning, and thank goodness, because they need to in order to meet the demands on them. And the problem really is demand. There is a supply-demand mismatch, and it is critical. It is existential in its problem. The talent shortage is unbelievable. Now, let me tell you just how much it is in case it seems small right now to you. This graph shows the percentage of companies that cannot hire the software engineers that they need. 75% this year, or last year, 2022. Look how it's ramping up. That's because demand continues to increase as companies realize the value of becoming more of a technical company, but they don't have the labor pool to pull from. It's up to you and me. What are we going to do? Create students out of the thin air? Maybe. Could we take students from other countries? Maybe we could just import talent. Well, not so fast. Turns out that the United States is just one of every other country out there. We all have the same problem. It is an intractable problem. Really difficult even to pronounce. All right, so what are the real numbers? Well, in 2020, we had 53,722 graduates getting a CS degree. Now, I know it's not a perfect match of software engineers to CS degrees. It's a pretty good measure. Let's say it's off by 100%. That's pretty bad, actually, but let's just say it is. 100,000 brand new engineers that year. So we're getting close, right? Far from it. Bureau of Labor Statistics says the scarcity of engineers in the United States will reach 1.2 million by 2026. That's in 3 years. That is in 3 years. If we were producing 100,000 engineers a year, well, obviously, even at that rate, we're not hitting it. But let's say we did it again with another 100,000. It would still take us 12 years to get to the demand that's going to be here in 3. That's why I said it's kind of an existential crisis on us. How are we going to solve this? There's got to be a way. There are probably many ways, a list of ways. And one of them might just be what OpenAI has shown us. OpenAI shows up. We know, of course, they've been around for many years, but they kind of showed up on everybody's radar last year, and we did what we do best as academics, right? We decided whether to ban them or not to ban them. I understand, right? The New York Public Schools, they banned it, and why not? Because it is brand new. We don't know how to handle it. We don't know really what we're going to do just yet. But remember, this is a train that's coming in as unstoppable. We can see that right now, 2023, it's a $164 billion industry. Jump up to 2026. Remember, that's the year where 1.2 million engineers are not available for the demand. That now all of a sudden it's $433 billion in size. We cannot stop this from happening, and we have a responsibility to our students as well as society to be able to prepare them for the real world that they'll be graduating into, one where AI is sitting right next to them all the time and they need to be proficient with it. This isn't the first major watershed moment in education. We thought calculators would be a big deal. Let me just make a quick comment that calculators were a big deal, and we still teach our students long division. However, once they learn long division, the expectation is they will never do it again because we want them to do higher math. We have calculators to do the long division for them. Make sense? All right, so we had the idea, we had personal computers, we had CAD that we thought was going to destroy architecture. It did the opposite. We thought the internet was going to ruin us. Now it's a fundamental part of our classroom. And certainly COVID threw us for a loop. 2022, just last year. Now we have DALL-E and we have ChatGPT. DALL-E was the ability for me to type in text prompts and get back images, and it was astounding. ChatGPT is that large language model the reason we're here today is because that large language model allows me to interact with it just like a person, and it interacts with me just like a person until it doesn't. So maybe let me cast your mind back to when you were in college. Do you remember that roommate? It was a great roommate. That roommate would stay up with you through the wee hours of the night and debate your ideas. That roommate would help brainstorm your thesis and work with you through the problems in your class. That would also do one more thing. It would, even at the 11th hour, when you waited for the last minute to write your essay, they would proofread it for you and check your grammar. Is it possible that these ML models are going to be like a better roommate? One that's always available, one that is incredibly smarter and with perfect grammar? Maybe. So we asked professional developers, how much time do you spend just searching for answers? On a daily basis, about an hour. Look at the chart for yourself. Well, that is because they are searching the internet, and if anybody's good at searching the internet, they are, and they coalesce these ideas and they synthesize their own answers. But what if we had an ML model that could search the internet for you and could do all of that much faster? Could we create time in the hands of engineers? I think we could. Sam Altman, he's the CEO of OpenAI, he said, we know that ChatGPT has shortcomings around bias, and this is what he means. Bad data in, bad data out. But the problem is bias is nefarious. It is because of filtering, right? Where we falsely identify certain parts of data as unreliable. And so it is filtered out. Or maybe certain types of sources we choose based on categories of sources, or the language, not just the language, but even the tone of language can change the meaning of the article because it's written by humans. And don't forget, humans are also behind the scenes. They can decide certain sources are removed or added depending on their own preferences and biases. Then the model itself has inferences that are nothing but trouble. Bad data in, bad data out. And we care about digital inequity as educators as well, making sure that this is still affordable and available to students who may not have the same luxuries as the rest of us. And we also care about accessibility. You and I may not be using screen readers, but we might be. And we want to make sure that all of these tools are available to everybody. It's good to remember what Abraham Lincoln said. Machine learning accuracy is very important to me. He was ahead of his time. So let's go back to Sam Altman, CEO of OpenAI. ChatGPT is incredibly limited, but good enough at some things to create a misleading impression of greatness. It is a mistake to be relying on it for anything important right now. And yet we do, right? We feel like we want to. There's an accuracy just from imprecision. This is a model, not a calculator. It's trying to find the most probable answer and get as close as possible. So when I asked it what 355 times 455 was, it told me it was 161925, but when I pulled up a calculator, it's 161525. It was close. And if it was just English and not math, close is pretty cool. Math needs to be precise. Inaccuracy through imprecision. This one was in the news recently where the ChatGPT AI inside Bing was showing the pros and cons of different vacuum cleaners. And one thing it does that's special is it includes a link to the sites where it gets its information, which is pretty neat, right? Until you click on it and you realize those pros and cons aren't in that site. It gets inaccuracy here from imagination. Literally, these models are able to hallucinate based on probable truths. And then it starts producing those. It's interesting and good to know. Another one is just around ignorance. So I asked it, what does the file keyword in C# do? And it said there is no file keyword, which is wrong. That's because it wasn't trained on information relevant to the file keyword. You're going to need to know. What was it trained on? What was it not trained on? Do you know? How could you know? So here are yet other things for us to think about. The problem is, though, our intuition says it's just so freaking smart. But I think you can explain that with the Dunning-Kruger effect. This is where we wrongly overestimate ourselves, just like we do with the AI, right? Our relationship with the AI starts by saying, it's amazing and my life will never be the same, and immediately tanks. Where we realize that it's making things up. This is a scam and I don't want to be involved with it. And in our calmer moments, we turn back to it and we're like, wait a minute, I'm just using it wrong. Maybe there is a way for this to be in my toolbox, and we start trusting it again, but just a little bit. That's the roller coaster relationship that you've probably already experienced with ChatGPT. From a legal perspective, I think it's important to at least talk about what original content is. So let me give a prompt to ChatGPT. Write my brother an email telling him what I've been up to since Christmas. It does. The problem is ChatGPT doesn't know me, my brother, or what I've been up to since Christmas. So it writes something like this that says, one of the biggest things that happened since Christmas is that I started volunteering at the local animal shelter. But I didn't. It just used probability to kind of guess what would be right. However, what if I changed the prompt to be more thorough? What if I gave the prompt more context and information so that, right, my brother telling me how much fun we had at Christmas, how I appreciate the sweater that I received, and my daughter Annie looks forward to his visit in May, especially with dog Marley. Now all of a sudden the letter it generates is based on information that I've given it. And instead of finding probability and hallucinating an answer, it actually is expanding my prompt and writing things like, Annie's been looking forward to seeing you again in May when you visit. She can't wait to play with Marley, your adorable dog. I do not write to my brother like that, but nonetheless, the letter is that much better because it is expansion of the prompt. That's what I think is coming. I think there's a new language and that's imminent, some sort of prompt language, a kind of recipe for these AIs so that we can say, we want this type of casserole, here are the ingredients, and here's the cooking instructions, now do it. And it is more efficient at making a casserole. We are more efficient at creating a recipe. I think it's inevitable that we will be teaching our engineering students how to write prompts, how to write requirements, how to write acceptance criteria more clearly, more plainly, and more often. Here's an article, ChatGPT, and it's copyright chaos. This is a problem for the legal field that you and I don't have to deal with right now, but this is what's going on. If a person writes a brief instruction to ChatGPT, write a story about a girl riding a bike, it is unlikely that the resulting text would contain enough human creativity to qualify for copyright law. However, if a human were to continually modify and direct GPT to fine-tune the story, it seems that the resulting text may be eligible for copyright protection. Why? Because the prompt is the content. The output of the AI is not. Weird, right? They have a tight relationship. Here's what you need to know about copyright right now. U.S. copyright law does not protect text, pictures, art created by machines, computers, animals, or any non-human creator. Got it? So if it was created by ChatGPT and you get it, there is no copyright claim. It's yours. Fascinating. Not so fast. Let's read the terms and conditions that OpenAI just updated. You are responsible for content. They used to just give you the content, but now they say you are responsible for content. That's the input and the output, including for ensuring that it does not violate any applicable laws, especially copyright. Now, why would they add that? The reason they add is because you can ask a question to this AI that is so broad that it can find 10,000 articles on the internet, coalesce those together into an answer that really is net new. It is new content for you. But you could also ask a question that is so specific that there is one article on the internet that talks about it, and all it can really do is produce a derivative of that article. Nothing that's net new. And a derivative of original content is a copyright violation. Fascinating. Now you need to know where it got all of its information. Do you know what ChatGPT was trained on or what it was not trained on? I don't. This is relevant, especially to software engineers who are getting code from ChatGPT, which brings us to academic integrity. Let's talk about academic integrity because that's what really matters to you and to me. So let's use the context of how to open a SQL connection. That's pretty common, right? I want to write or read a database. So the first thing I would do naturally is to go to the online docs. I would find the example provided to me by the online doc, and I would use it in my code. Do I need to cite the online doc? Is it cheating if I use that example? Think about your answer. What about if instead of the online docs, I just find it like everybody else at Stack Overflow? It's the same code. I copy it, I put it in there. Do I need to cite that block of code in my method from Stack Overflow? Is that normal? If I don't, is it cheating? Am I violating academic integrity? What if instead I go to GitHub and I filter to only the repositories out there that do not have a license, that I can use their code freely, and I find that they have done what I want to do as well, open up a SQL connection, and I take their code? Do I need to cite GitHub then, even when there's no requirement for citation based on the license? What about when I open up Visual Studio and I have Copilot installed? And based on just the name of the method alone, it gives me the block of code to create a SQL connection. If I accept it, am I cheating? What about ChatGPT? ChatGPT, that ML model that I can talk to, and I can just say the exact same thing, and it gives me the same code that I would have found in the docs. Is it different in your mind? Is it different that all of a sudden, because it's from ChatGPT or some machine learning model, that there's a level of cheating that's different than seeing the code as an example on online docs? Does our definition of academic integrity meet reality? Should we reconsider what we're doing? Let's think about this. If you have Microsoft Word and you type a sentence, the machine learning grammatical service inside it will give you a more clear sentence. If you select their suggested sentence, do you need to cite Microsoft Word? It's still an ML model. These are things we need to just consider. The other thing we'll consider now is just like what changes in the classroom. There are many things that change in the classroom, especially when it comes to computer science. And the first would be around assignments. We know that we need to stop with rote assignments, right? We know that early in your college career, your first year, first few months, you're going to need to learn syntax and prove you know it fine. Yes, I understand. I'm just talking about as we move forward. Many rote assignments are because you and I as educators just don't have time. Now we need to think about teaching things that are around design and the ability to review code and the availability to debug code. Because as the AI gives us new code, we need to be able to process it. We need to be able to deal with it. It's a big deal. So these are the skills that are the future skills. What about assessments and how we test? Well, we need to test systems instead of syntax. We need to start testing patterns because that's what is going to matter. That's where the human intuition is going to pay off. We need to maybe even revive oral exams, right? Maybe they need physical presence right in front of us because after all, we are an accredited organization. We are giving you a degree. We need to make sure that you really are learning. I think we could see that happen. I think we could really see that happen. We may even need closed workstations where we can make sure that there's no AI being used during the assessment. What about experiences? Well, the experiences will change because they'll be more accessible and involved, more personal, and more consistent. Let me explain. Let's pretend I go to ChatGPT and I say, write an exercise on how to filter an array, and it does. Now, I could write my own. That's fine. But let's pretend I write my own, and I give it to ChatGPT, and then I say, take that same exercise, but make it interesting to art students. Take that same exercise, make it interesting to girls. Take it and make it interesting to NASCAR fans. Make it interesting now to ROTC students. And you can see it's still the same assignment. It's just changed a couple of things to make it more applicable because we know that the adoption of these engineering practices to students who are just curious and interested, and they come to your class and they want to be engaged, but they don't feel there's any personal connection. Now I can do that. And I could even say, make it interesting to our basketball players. And perhaps most importantly, since this is an engineering audience, make it interesting to Star Trek fans, right? Because we want to make it so it's accessible. We want to make it so it's involved, more involved. We want to make it so it's more personal, but also consistent. So let's keep going and I'll show you something. So I might ask ChatGPT, let's make a rubric around this assignment. And it gives me one. Now I could make my own, but let's just go for it for now. Maybe I paste in my rubric. That's fine. And I can say, based on that rubric, take this assignment from this student and grade it. Now it gives me a grade. How beautiful is that? Because it is, again, like my roommate who's right there is like, hey, did you even see number 5? I know she didn't grade number 5 yet. And I can say, well, okay, I'm going to give it this grade, but I can at least have somebody pushing back on me to make it even better. You only have so many hours in the day. How many students do you have? How many classes do you have? Is this an incredible benefit, perhaps, to faculty as much as it is to students? And then look what you can do. I can say, let's write a letter to that student whose name is Jerry and explain that grade. I can add more information about the student as well. So when the letter is written, it is a personal letter. And the personal letter makes reference to the actual assignment that they turned in that was unique. That is really, really cool, right? I would be irresponsible to take this letter and send it to a student without first editing it. However, what an incredible starting point. That's because it's all about making it more accessible, making the student more involved, making the assignments more personable, and also making the grading more consistent. But there are things that do not change. For example, the learning mindset never goes away. It will be a lifetime of learning, and that's what we want it to be. Who knows where we go next? We're predicting the future. We could easily be wrong. We'll never get away from critical thinking. We know that they're going to come up against things that they've never seen before. We need them to be able to understand them and just rationalize their way around them. That's important. And we want to give them the maturity to be able to handle a complex real world that's coming at them when they graduate. So let's predict the future together. Right now, what does all this AI business mean? Well, right now, it means that engineers will continue to code and they will start dabbling in AI. There's no getting around it. What do we do in the short term, though? The short term is just around the corner. The short term is where engineers continue to write code and they start to rely on AI. This is where you and I as educators need to prepare our students for the real world that they're going to graduate into. There's kind of a midterm coming. What's coming right after that? Well, this is where the AI is relied on even more to write even more code, but the human engineer is now validating that code to make sure it's secure, to make sure it's performant, to make sure it's scalable, to make sure all of the things that are necessary. And then there is a long term. And what is that? The long term is where the AI is doing all the coding and all of the reviewing. But the engineer is responsible for that language, that prompt language, writing the request, writing the acceptance criteria, right? Being able to take all of the characteristics of what the software needs to be and communicate that from the business in a technical sense directly to the AI. Right? That is the long-term future. It's inevitable. We can all see that it's there. It could be a long way away. It could be a short time away. I'm not going to bet either way, but it is inevitable. And for us to say it'll never happen, that's ridiculous. Okay, let me leave you with these questions for you just to ponder. First, what is your own attitude towards technology, especially around things like ML and ChatGPT? When you see content that was originated there, do you look at it differently? Do you think about it differently? Do you all of a sudden just write it off? I mean that honestly. You need to ask yourself. I ask myself all the time. Okay, are your assignments, are they mostly rote or designed because we know they need to be around design? Rote is important, but that's a short-term issue. Design is the long-term value. Do your assessments test knowledge or understanding? This is an age-old question, of course. We definitely want to be testing understanding because knowledge is something that can be supplemented by an AI. Are you preparing your students for the real world they'll be graduating into? One where AI is ubiquitously everywhere. This is an imminent issue. And you and I, we have responsibility for our students to be prepared for it. What do we need to do? What are the pivots in our classroom? Some of the things I've mentioned, but maybe others. Can your students communicate requirements? Do they understand what acceptance criteria are? Turns out communication still is one of the most valuable things that any engineer can have. Maybe more important than ever. Communicating to a computer? Yeah, absolutely. Who better to do it than a software engineer? And then finally, is your definition of academic integrity realistic? Do we need to change what it means, right? Because it comes from a machine learning model, am I cheating, right? What does it mean to have original content? What does it mean for me to need citation? Just things we need to revisit. And I'll leave you this most important thing. So you know I'm a Star Trek fan, and I really am. And so Star Trek, The Undiscovered Country, that's Star Trek 7, my favorite movie. The Federation is trying to make peace with the Klingons, and the Klingons say one of the most profound things I have ever heard. If there is to be a brave new world, our generation is going to have the hardest time living in it. You and I as educators, this came on us fast. We are going to need to pivot, and we are going to need to deal. But we want to because we have embraced education. We are educators. We love our students, and we want to prepare them for the real world. There are things we need to consider, important things, and we can do it together, sharing with one another. This is a fantastic conversation that certainly doesn't end here, but this presentation ends here. Thanks for listening.
Jerry, thank you for that great talk. We've got a bunch of questions let's start with this first one. Says that you posed the question that ChatGPT could be a better roommate. You also said that software engineers need to have a learning mindset, have critical thinking skills, and be socially mature. If ChatGPT fills in for the roommate role, how do you think this will impact maturing society? Maturing socially, sorry.
Well, I suppose we need to define what it means to be mature socially as well. I think at its simplest approach, if you're socially mature, you're able to deal with a society that is both kind of randomized as well as difficult. That's one of the things we do in our classroom is try and create a scenario where students are exposed to difficulties and not given necessarily the hand holding they're accustomed to as they were growing up. And so now they're in a place where they're needing to move really quickly, have their own kind of mental agility to deal with things. It's not so much whether or not you're able to make friends. That's not what social maturity is about. Social maturity is really able to deal with society in a productive way. And I mean, if I kind of go back to my own roommate and I think about how much my own personal experience with my roommate in college helped me mature and be able to make friends. Yeah, maybe a little. That's not the goal at all. The goal of educators is to be able to prepare them for society, to be able to make sure that they have the emotional maturity to be able to deal with things like failure and rejection, but also the social maturity to be able to deal with difficult people and kind of a lot of randomized things that happen to them in both their career and society itself. So I think maybe that's just a misunderstanding. It's not really about making friends so much. It's more about just being able to deal with the things that naturally come from them. So how will ChatGPT help with that? Well, it'll help with a lot. For one, it'll give them a lot of tools in their toolbox to be able to deal with things that are difficult. So, you get caught off guard and you're back on your heels and you're trying to figure out something that's difficult to kind of understand. Now you have something that's right there ready to brainstorm or even pick apart the ideas that you have and talk about something you can talk to that doesn't have any judgment at all. Sure, it might have sort of judgmental language that we've joked about here, but at the same time, the reality is it's just a machine talking about and saying, hey, this doesn't really equate to this, or it does equate to that. So I think it's probably the best thing you can have dealing with difficult situations, something that knows almost everything, will argue with you without trying to get the better of you at the same time.
Yeah, I think another fascinating aspect, though, is the idea that these technologies might actually prepare us to have harder conversations in like a safe space, right? Where you could imagine over time, like different types of personalities that you could safely practice interacting with. So I think there's some really interesting things to explore there as well. But I agree with what you're saying there.
Yeah.
So
well, I mean, you could ask GPT to act mean to you too, right? You could say,
yes,
be aggressive back to me so I can practice for an interview or something along those lines.
Right.
And you use the right word. It's a safe space. It's the safest space you could possibly be. It's just you and your laptop.
Gaslight me. No, please don't do that. Okay, it does that pretty well. So ChatGPT and other models start to hallucinate based on probable truths.
Yeah.
Society today has a problem with disinformation and untruths. If humans create the recipe and ChatGPT creates the casserole, how do we get the hallucinations out? What a great question.
Yeah, that's a really good question. And you could apply that question to things we do today, and then you could start to see the answer kind of come together. So right now, when I go to look up just a coding solution and I go to Stack Overflow, it will give me the answer. And when I'm looking at whatever that answer was from Stack Overflow, the reality is Stack Overflow is often wrong. And it can be upvoted 150 times, selected as the answer, and everybody comments thank you to it, but it can still be the wrong answer. And it kind of goes back to your roommate. So you're talking to your roommate, you give them let's say an essay for them to proofread for grammar. They aren't responsible for the grammatical correctness of your essay in the end. You still are, regardless of whatever it is that they do. So now I go to Stack Overflow or anywhere else, and I get some sort of solution, some sort of technical solution. I still am responsible to make sure that is still up-to-date syntax, still the correct way to do it, doesn't have some sort of logical flaw or some sort of security problem inside it. If I get that from ChatGPT, none of the rules change. It just happens to be another source of information.
Awesome. Next question. Machine learning and large language models have been around for years. What's so special about ChatGPT that has brought it to the mainstream and having this explosive growth that we've talked about?
Gosh, what do you think, Glenn?
I think the conversational aspect of ChatGPT has just made it so approachable. It makes, there's lots, even when they had the API, you kind of have to understand more about machine learning. And the fact that ChatGPT just allows any person to come in. I don't have, like, I've led teams that did AI things, but I'm not like an AI expert.
Yeah.
And I just got engrossed. And then the other thing is the progressional aspect. You could start off, everybody starts off just asking it a simple question. And then this thing dawns on you about the prompt and how powerful you can, how powerful the possibilities are if you start to feed it more context. And then you start to learn tricks like table. I just think it's got this evolutionary aspect to it that I think just pulls people in, makes it really easy to start off simply and then just go from there. I think it's that and just the buzz. It's just had an incredible explosive buzz about it. It's everywhere.
No doubt it's part of its popularity is just the excitement of everybody doing it at the same time. But if you look back, we have to teach people I have three daughters. So as they were growing up, I had to teach them how to search the internet. So, you can just type in whatever it is you want, but there are ways to like tailor your query inside a search engine to actually get better results and block certain things out and things like that and get better. And then we see the kind of progression of that where you can use plain English in a query against data. And even then you have to use certain terms to be able to represent whatever the items are inside your data sets. But all of a sudden we get to something like this, and you can write the sloppiest, craziest, and kind of long-winded or short-winded, whichever way you want to do it, kind of question to it, and it still gives you the same answer and is able to figure it out. I think that's probably the part that people are dazzled by, because they realize I don't have to go learn a syntax, I don't have to go learn a special way of doing it, and it has this awesome kind of secondary benefit of it doesn't find that website that answers the question. It finds all 4 websites that answer the question and then coalesces them together into a single answer.
The distilling,
sort of
I think the distilling of the data is just amazing. The other thing is typos. Like it ignores typos. It's able to, I've made so many weird mistakes and it just gets the right thing. It's really like, wow, how did it do that?
Yeah, I don't even think there is an advantage in doing things like a plus sign or putting things in quotes or making sure that your parentheses are right in the you just write it as if you were writing to the guy sitting next to you, and it's just a normal conversation. It feels like a normal conversation, but it's just able to do some smart parsing.
Yeah, so gentlemen, definitely.
I have a question from the chat from Mike Baker. It says, if I determine that ChatGPT has given a wrong answer, how can I report it? How can I get it to believe the correct answer? And how does it know whether my answer is really the correct one?
Well, you can report it easy enough because there's a little down arrow, a little down thumb right next to its answer. But you can't get it to, even if you were smart enough, and trust me, we have all tried this, to like train GPT ourselves to make it believe some sort of crazy thing or get it to say something that it's not supposed to say. Like whatever it is, we've all tried. Once you open a new tab and you're in another conversation, it's forgotten everything you've done anyway. So don't waste your time trying to teach GPT something, because that's just not the way it works. You can ask,
and there's value in that though, right? Because that was the problem with Tay. Like I thought that was brilliant early on. The fact that they created that isolation, even at the level of the session, is brilliant, because it means that, like, sure, within my session, maybe if I even succeed in teaching it to be racist or hateful, that's going to stop as soon as I leave. Like, it's not going to roll. And look at what happened with Tay. I mean, seriously, like 24 hours, that thing was spewing hatred, misogyny, racism, whatever. So I think that's really excellent that they created that model.
I think one of the things that Tay had that didn't have that we have here is there is a lot of human curation going on here behind the scenes that we don't necessarily see. Like nobody is sitting still and saying, let's see how this thing performs. It is, if you use it a lot, you know that from a day-to-day basis, it splits personality all of a sudden. It's totally different. When I first started using this, I got involved in probably January. And when I first started using it, it was, compared to today, it's not even the same system. Like it doesn't even act the same, let alone say the same things.
Yeah, no, I started around November, December timeframe, and it has just been, I mean, at that time, you didn't even have the log of what you told it. Like, it was very, like, you just said what you said and it went away. It has definitely been evolving at a rapid pace, and also important to say that it hasn't had its share of controversy around the curation of the data, especially and it's a really, I don't know the right answer, but the way they've used humans to have to look at information that is very harmful in order to help train it to recognize things that are very harmful. It's like this really interesting ethical quagmire.
Yeah.
And it's
And
what
I'll
made
say in
the
the early
result
days, I could
better.
get it to say about anything, but you got to work now. I mean, you got
Yeah.
to really work at it. So
Yeah.
So
they're
Jerry,
definitely making a difference. I think it's a positive one for sure.
uh,
And the thing is, people are like, oh, is it politically like left, politically right? I'm like, who freaking cares? Is it able to do what you're asking it to do? You're leaning too heavily on this. It's not a real roommate. It's just a system.
Right.
We're just talking
Right.
about how it could help you.
so Jerry, I have a question, another on the chat about one of your slides. What's the nominal timeline in that short, medium, long-term slide? Couldn't we change the LLMs together, check the output of one and the other to speed up or shorten that timeline?
Well, who isn't surprised at the timeline so far? I mean, we all kind of knew it was coming, and then suddenly it just drops on us. We didn't realize it was so close. I think it's okay to think about this as it's not, it's a long way away. I think we want to say that to make ourselves feel better. We're like, it'll be a long time before we won't need engineers. That's probably true. But how long will it be before AI is able to act and code like an engineer? I mean, we'd be fools to say it's a long way away, to be honest. I mean, everything is just too close, too fast. I mean, today, ChatGPT, it doesn't have a lot of like value because it is wrong so often. What it does have is a lot of like potential. That's what it really has. And so to kind of see it there, like we got to this point where we could prove that this could be done. How much further to be able to prove that it could write a method for us? That's easy enough. To write an entire class in a method, already does that. To write an entire solution, well, that could take several months, years. I don't know. I mean, do we need another decade to get there? I don't think that's the case. I think those are like short, medium, and long term, just to see that what the steps will naturally be. If anything holds back AI, it's going to be the human factor of holding them back, either artificially through some sort of weird regulation, or just practically that we can't have it build this much code without us reviewing it. So it's going to take a certain amount of time for us to review it. And it's going to take a certain amount of time for us to be able to train engineers to review AI generated code. One amazing thing that I think that we haven't even thought about is that once AI is writing code, things like C# will be gone. There is no necessity for an actual language for it to write in other than directly to the machine. These ideas of like design patterns and all of the complex, is this a messaging pattern? Is this an offloading pattern? Is this, all of those things will be gone as well. We won't even look at how it's written because we use those patterns partly to make sure things are done right, and we'll be able to test them on the other side to make sure we don't need those patterns, but also because we need it to be maintainable by humans. And if we don't have those sorts of patterns and languages and code standards and things we have today, then it can't be maintained. The idea of maintaining AI generated code, that won't even be a thing, because what we'll have is we'll have AI will write the code. It'll be wrong. It'll just rewrite the entire line of business application from scratch. Like, it doesn't need to go in and tweak and fix different bugs. It can just
Hopefully
write it
not for
again and
one.
again.
Hopefully not for one bug.
Well, yeah, that's right. Well, it depends on how long it takes.
Rewrite the whole application.
Yeah.
Whoa, gentlemen, wow, I'm starting to feel really old already. Well, thank you so much, Jerry, for your talk, and Glenn for asking questions. It's time for us to move on again.
I feel like we did another talk. This was awesome.
I know. So let me remind you of, as Peter mentioned at the very beginning of Code Campfire, that we're going to shift gears. And our next two sessions are going to be very technical. Put on your Code Camp t-shirt. And it's going to start off with Carson Lamb. Carson became a practicing ophthalmologist in 2016. And a couple years later, he had his first side gig as a data scientist. And over time, that side gig expanded, and he became a machine learning researcher and then machine learning engineer. And about 5.5 years later, Carson just hung up his doctor coat, his white doctor coat, and dedicated himself fully to a machine learning career. So Carson's now going to take us into a really deep dive into a corner of AI show us some code, show us the math behind the code, hang in there for that deep dive. And then we'll come back for one final presentation from Jun Ling, who will take us back up a level and talk about the science behind what makes ChatGPT work. So Carson, please take it away.
Hi, nice to meet all of you. My name is Carson Lamb, and what I want to do for you today is give you something that I think is harder for you to find for yourself, which is I think that all of you are interested in this ChatGPT machine, and it's a very large, complex machine. And so I want to show you a version of that that's very small, simple, self-contained, so you can fit it in the palm of your hand and take a look at it, take it apart. And I want to do that for you because that's how I learned the best. And I think that many of you probably learned that way too. Several years ago, I was actually a practicing ophthalmologist. And today I lead a team tackling machine learning problems. And so that's a big jump. And the only way I was able to do that is I was willing to stare at things that uncomfortably made me feel like I didn't understand any of it for a long time. And I was willing to revisit that later on. And that's what I'm going to do for you here today. A lot of these things in this talk you're not going to understand the first time around, but don't worry, there's no test on this afterwards. So all I expect from you is just to be open and just take from it what you can. And if you're doing that, you're doing your best and you have nothing else to worry about. So let's get started. Okay. Will ChatGPT do X? ? Build your own Mini-ChatGPT and then decide for yourself. So what I want to share with you today is a focused dissection of the implementation details of a small, simplified, self-contained toy project demonstrating reinforcement learning from human feedback with special emphasis on connecting the equations describing proximal policy optimization to the lines of PyTorch code that apply PPO to work with sequences, such as completing sentences so that they end with a positive sentiment. We do this not by self-supervised or supervised learning, but rather by letting the model generate text on its own and learn from scores assigned to that text after it is generated. This is analogous to the way ChatGPT was trained using human scores of model-generated answers to instructions. We end by discussing what we know so far about the properties that emerge as these models are scaled up. My name is Carson Lamb. I'm a machine learning engineer. I lead the AI team at a startup called Carrot Coach. We provide home health aid to persons with special needs using our technology. With regards to this talk, an even more detailed version of this tutorial in the form of Jupyter notebooks can be found at my GitHub and at this link here. It has links itself to better explanations of a lot of these concepts in case a lot of this passes you by and not able to capture it in this talk. You can always revisit it. This work borrows heavily from the work of Leandro von Juarez, TRL repository that has been improved by Hugging Face engineers. And the TRL repo on GitHub itself is based on OpenAI's baselines repo. I also take several figures in various from various blogs and scientific publications mentioned here. Lastly, some of the people I take inspiration from and have to thank for their simplifying of AI concepts for thankful students like myself, Andre Karpathy and Chris Ola. Okay, first let's define some terms. First, in this talk, when I say transformer, large language model, foundation model, agent, and policy, I mean the same thing. And when I say that, generate text, emit a token, sample from a distribution over the vocabulary, take an action, I also mean the same thing. Most tutorials on reinforcement learning today describe the process of reinforcement learning as an agent reacting to the state of its environment by taking an action, observing a reward and change to its state, which presumably was affected by a past action, Then over the course of many of these state action reward sequences, learns a policy for how to act that maximizes the reward over some predefined time horizon. In reinforcement learning from human feedback, for text generation, the state or environment is the input prompt, such as the instructions to ChatGPT or the incomplete beginning of a sentence. The action is how the language model chooses to respond to those instructions, or what tokens the model samples in order to extend the sentence. In the example above, suppose our language model has a tiny vocabulary of size 9 possible word tokens. The green fourth bar down corresponding to token ID equals 4 is the word cat. The tool that helps us go back and forth between the integer 4 and the string cat is called the tokenizer. When the model is prompted with the incomplete sentence, I saw A, the last token A induces the model to output a probability distribution over all of its vocabulary. The length of the bar represents the probability assigned to the word cat. During pre-training, every time the word cat comes after I saw A, the cross entropy function updates the model to increase the probability assigned to cat. So reinforcement learning is a different way to update the same model because, of course, there are many valid ways to complete a sentence, to answer an instruction, and there are also many invalid ways to do these text completion tasks. Instead of using a cross-entropy loss function, which is analogous to asking the model to memorize many sequences and then interpolate between what is learned, which can still do amazing things, as most of us here know already, we elicit the model instead to using a prompt to generate a new sequence of tokens and then assign scores to those completed sequences. Reinforcement learning is about designing training processes to update the model to effectively maximize those scores. So this process is outlined in step 3. And so step 3 is what this talk will focus on, because there are already so many ample resources explaining step 1 and step 2, which uses standard self-supervised language modeling techniques, such as predicting the next token in a static data set, or in the case of reward models, uses supervised learning from human labels. Okay, so let's start building. First, the data set. The data set is like a large collection of sentences, in this case, or in ChatGPT's case, a large collection of instructions. But we're going to start small, so we're just going to do incomplete sentences here. Usually these sentences are larger than 8 tokens long. So it means that if we take the first 2 to 8 tokens, we will have the beginning of an incomplete sentence that we can use to prompt our policy to generate the rest of the sentence. Next, we initialize the language model that we will update using reinforcement learning from human feedback, RLHF. We'll call this the new policy. That's the one we update. And we'll also hold on to a static version of the original pre-trained model called old policy, and then a tokenizer that maps between integer IDs and their corresponding substrings. Remember, for us, taking an action means outputting a probability for each token, then choosing one of those tokens to be our next token, using that token to extend the sequence by 1, and repeating the whole process again until we, for example, hit a stop token and then we know to stop generating forward. If you always choose the most likely token, that's called a greedy strategy. We are not going to do that. We are setting the do sample argument to true in order to generate a diversity in our actions. So it's stochastic, essentially, the way that we're going to generate. We will take 4 to 16 steps into the future. In other words, we will extend the prompt by 4 to 16 tokens before we assign a score to the final sequence using a reward model. Next, the PPO trainer turned our dataset into a data loader, which is an iterator that I can repeatedly ask to give me batches of starting prompts. I would consider this data loader to be analogous to the environment in the sense that the start prompts or the beginning of sentences are kind of like states in typical RL. It keeps presenting new states and eliciting new actions from the policy. You will see that in the Mini-ChatGPT repo, these start prompts are called queries. The text version is displayed here, along with below it the token ID version of the same queries. And those IDs are what are inputted to the model. So these queries are then fed to the policy to generate the rest of the sentence. Gen length means generation length. It's a number between 4 and 16 that will tell the method called generate how many tokens to extend by. Printed out are the new token IDs generated by the new policy, which we call responses. Below, I have used the tokenizer to decode both queries and responses back into text, and then put them side by side, separated by this special symbol to make it more clear and confirm what's happening. So take note that there are 4 sentences in this batch. So our reward model assigns a score between a desirable +2 and an undesirable -2 to each of the 4 sample sentences. And now with these queries, responses, and rewards, analogous to state action rewards, we perform one PPO step, update step. But before we zoom into the PPO step, let's zoom out and put everything into context before we get lost in the details. Okay, so on the left here, the code. All I've done here is placed those same lines of code that I've already shown you, but I've placed them into a for loop. And with each iteration, I collect the average of the rewards into a list called rewards list, and then plot those average rewards for each batch in orange in the plot to the right. And if you try this yourself and print out the sentences like I did in the previous slides, as you go along, you'll notice that they get more and more positive sounding with this approvally quality to their sentiment as you watch that orange line go up and to the right. I will go over what returns are when we dive into PPO. And the next slides, just so you know, they all take place within the PPO trainer .step function. There are other RL algorithms to use besides PPO, but whichever one you choose, you probably have some risk of distributional collapse. That's when RL updates cause the model to deviate so much from its initial pre-training that it starts to speak nonsensically, or in physical environments, for example, forgets how to walk, jumps off a cliff, learns these undesirable policies, thus adding noise to the training and making things worse and getting in the way of improvement. A technique usually found in RLHF used to avoid distributional collapse is KL regularization, or a KL penalty on the reward. On the left is equation 2 from the fine-tuning language models from human preferences paper. In this equation, X is the prompt, Y is the generated sequence, pi is the distribution of the new policy, rho is the distribution of the old policy, beta is a scaling term that is adjusted during training to incentivize the KL divergence. The Kolbeck library, I'm butchering that name, but the KL divergence between pi and rho to be some target that the experimenter chooses. For example, targeting a KL divergence of 6 nats, where nats is the measure of KL divergence, the difference between the 2 policies or distributions. The corresponding Python implementation of equation 2 is below it. Recall that log of a over b is the same as log a minus log b. When you take the expectation of equation 2, you get the expected rewards minus the KL divergence. The formula and corresponding code for the dynamically adjusted beta term is on the right, and I'll show later how we got the log probabilities from our new and old policies, but I want to give you the motivation of why we do this first. Notice that the first time this is calculated, the non-score reward, or the KL penalty, is 0, and that's because the new policy has not been updated yet, and so it's still identical to the old policy. And the final reward is just placed into the last position of the sequence for each of the 4 sentences. Okay, so to clarify the code for getting log probabilities, or log probs, I borrowed this figure from the Lambda paper, the one on the bottom left with the blue boxes. Notice that the sequence in the top row is the same as, but just one position behind the sequence on the bottom row. And that's because what is implicit in the diagram is that the blue boxes represent hidden states, also called vector representations, which in the top diagram is represented by a pink vector H. The hidden states of the deepest or top layer in the blue diagram also go through a linear layer that transforms the hidden state into a vector with a logit for each token in the vocabulary. These logits are pushed through a softmax layer so they can be interpreted as the token probability, at the token probability distribution. We sample this distribution at the top of one column, and that becomes the token at the bottom of the column just to the right of it. And you'll see in the code snippet on the lower right that the function f.log softmax is used to transform the logits output from the policy directly to log probabilities. Also notice the way the logits are indexed different from the input IDs or the token IDs. The :-1 and the 1: for the input IDs. That's because in the blue diagram, the logits that the token in step T is sampled from come from the logits at position T-1. Okay. Next, we're going to jump to the topic of advantage functions. There's already plenty of explanations of this topic with respect to reinforcement learning, and it's not specific to RLHF, so I'll only briefly describe it for the sake of clarifying why the code is written the way that it is. In simple terms, it's because it is noisy which actions lead to which rewards. When you define the direction and magnitude of benefit of your actions, it's better to use the difference between what I'm going to call Q minus V. So Q is the total rewards you think you got from taking this action in this state, whereas V is the total rewards you think you would get just from being in this state, averaged over all the actions you could take, including the one that you did take. In the equations at the bottom that all start with capital A equals, it's useful to group everything to the left of the minus sign into one term and everything to the right of the minus sign into another term, which is to the right of the minus sign, it's just capital V all the time. To the left, we'll call that Q, and Q has different versions. For example, R sub T plus V of S sub T plus 1 is a slightly more detailed estimate of the returns, because what R sub T means is it's the reward that we actually received immediately after taking action A sub T. And actually, you could make this more and more detailed by including more R terms in the future. And arbitrarily, until the end of the sequence, or end of the episode, obviously. I will refer to this as the short range versus long range estimates of return, or the discounted rewards into the sum of discounted rewards. That's the returns. The problem with longer range estimates is that you don't really know if the current action is what led to those future rewards or punishments. It could be a state in the past or future, or a combination of actions. So the generalized advantage estimation strikes a balance between the long range and short range estimates of returns by calculating an exponentially weighted moving average, the EWMA, for the advantage. The lambda is a weight parameter that, when higher, incorporates more of the non-immediate rewards into your estimate. The summation expression above is basically the formula used to calculate EWMA, which, if you follow the math, and there's more on this in the GitHub repo, in case I'm going too fast. But basically, the expression here says that you can start by calculating the advantage of the very last time step, or the very last position in the sequence, in other words. The symbol delta is used to mean the advantage at a specific time step, rather than a capital A, which is the EWMA version of the advantage that is a combined version of all these different estimates overall using lambda. I'll say this again. So we use the advantage at the T plus 1 position to calculate the advantage at the T position, and we use the advantage at the T position to calculate the advantage at the T minus 1 position, and so forth until we get to the first position in the sequence. To help you To help you when you study this on your own, I have put the mathematical equations above and the corresponding operations expressed in PyTorch code right below it. Another thing we need to do is, because we use this estimate based on the state of the returns called the value function, we need to continually improve our value estimator function as we train. And we do this by comparing the actual returns with our estimate and minimizing the squared error loss between them. This implementation detail is not explained in detail in the PPO paper, but when you look at the discussion in the OpenAI baseline repo, the authors state that they, quote, clip the value function objective to reduce variability during critic training. So here, the word critic means the value function. So similar to the surrogate clipped loss we are about to discuss next, they also clip the value function loss, and you'll see why clipping works in the next slides. Okay, so this method of stabilizing training is at the center of PPO, and it's called the clipped surrogate objective. Before I show the usual equations and code, let's just go through an intuitive explanation of the equation and what this equation and code does for us. What we will do is that for each of the actions our policy takes, we compare the probability of taking said action by the new policy with the old policy. And we represent this comparison using a ratio between the two, where the new policy is on top in the numerator and the old policy is on bottom in the denominator. So in order to disincentivize these radical, noisy, unconstructive updates to the new policy, we update our policy only if, and by the way, this comes from the Hugging Face blog on reinforcement learning. We update only if, one, our ratio is in the range 1 minus epsilon to 1 plus epsilon. So for example, if epsilon is 0.2, the range is 0.8 to 1.2. Or the other situation, 2, our ratio is outside the range, but the advantage leads to getting closer to the range. So there's 2 cases of this. The ratio is below the range, but the advantage is positive, so greater than 0. Or the ratio is above the range, but the advantage is negative or less than 0. So here's the equation on top and the code on bottom that that behaves as we have just discussed. Keep in mind the minus sign is in front of the advantage, so that flips the min operation to a max operation, and also that e to the power of natural log pi new minus natural log pi old is equal to just the ratio pi new over pi old. The expectation term means that we're going to take the average over several steps and several sequence samples. And just to emphasize again, r theta sub t is the ratio. It's not the reward. It's the ratio between the new policy and old policy. And for example, when the ratio is 1, it means they're the same. They're the same policy with respect to this particular action and state. And a ratio of less than 0.8 or greater than 1.2 means that the new policy is very different from the old policy by a factor of 0.2 in this example. Okay, so this is the combined PPO objective composed of 3 parts. There's the policy gradient part, the value function part, and lastly, the entropy part. The TRL authors leave out the entropy term because it didn't seem to help very much, and so they just decided to leave it out. At least at this point, we haven't figured out a good way to make it beneficial. And so, which is why in our case, when you see after we return the policy gradient loss and value function loss from the function above, the final loss that we back propagate on is this loss equals PG loss for policy gradient plus coefficient times VF for value function loss. And we maximize this objective, which is why there's a negative term in the expression in this diagram here for the squared loss, because if you maximize the negative of this component, it's the same as minimizing the component. Okay, so let's end off by zooming back out and looking forward to the future. So maybe some of you are disappointed that the Mini-ChatGPT was more mini than you had anticipated. Like for example, you asked it to write your midterm paper on the mating patterns of Gen 2 penguins, and it did not deliver very well. In the diagram to the left, though, you'll see that there's a distinct phase transition that occurs at certain levels of scale. Scale is measured here in training times parameters. And abilities mean things like few shot prompting, for example, that emerge unexpectedly and quickly as you gradually move up the scaling ladder. Research is still happening, but as far as we can tell, the same synergies between scale and few shot, for example, should still be true of RLHF, in that RLHF bestows a distinct change onto the model that is different from doing, cross entropy training on more examples of positive sentiment sentences, for example. On the diagram to the right, it's from Anthropic's paper. We see one of their papers. We see that with respect to human preferences, it can sometimes achieve rewards that otherwise would require a model to be 2 orders of magnitude larger in terms of parameters with current methods. It's possible. So the question of is it possible, and how do you anticipate these emergent abilities is a bit more complicated. You can't simply extrapolate from how a smaller model is improving because they're unexpected. But it is being researched. Like, for example, one promising area is the study of this phenomenon called grokking. And so I'll just end by reading you the quick part from that paper. The bottom paper's result shows that grokking, rather than being a sudden shift, arises from the gradual amplification of structured mechanisms encoded in the parameters, followed by later removal of memorizing components. So training, that they say training has 3 continuous components. First happens a memorization phase, and then a circuit formation phase, and then a cleanup phase where you erase out the memorization parts of the model. And then at that point, you see this emergence in the model. Okay, thank you very much. Bye-bye.
Well, thank you, Carson, for that excellent talk. It literally has blown my brain. I'm going to be going over it again and again and definitely playing with that code. So we've got some great questions here. The first one is, what is proximal policy optimization?
Yeah, so it's one of the many algorithms in reinforcement learning. This is the one that I think is commonly used with RLHF. And the proximal means
RLHF.
Sorry, reinforcement learning from human feedback, which is the method that was used to train ChatGPT and InstructGPT, which is its predecessor. Yeah, basically, when you're using instead of training a model to essentially, I wouldn't say memorize is kind of, maybe memorize a bunch of data. You instead train a model that tells whether the model is doing a good job or a bad job, and then you use that model from a reinforcement learning sort of pipeline to train that model to do more and score higher on that reward model. And so PPO is the one that's common. You can use other models besides PPO to do RLHF, but this is one model, and it's called that because one problem that the reinforcement learning community is still dealing with is trying to get reinforcement learning to be less noisy. Like a lot of these video game, if you read like how they trained these video game reinforcement learning agents, it runs for a very long time. It's not like human beings. Like you show a kid a video game, and they'll play around with the joystick, and they'll figure out how to play the game fairly quickly. Like they're not going to play the video game for millions of hours or something like that to figure out how to jump over like this pipe, if you're Mario. So the way the PPO means that it's allowing the model to not sort of what's called distributional collapse, which means it's very easy to update models in a way that destroys how the model is functioning. And kind of like, for example, if you imagine you could never, you never say never, but it'd be really hard to do this on a real car, because that car would just be crashing into the sidewalk, crashing into poles all the time. You would have to buy like a lot of cars to train it in real life. And so you want a car that like sort of drives okay, and then like you keep it and then you teach it to do what you want it to do better, but you don't want it to lose too much of its original, I guess, knowledge or behavior. So that's when you want to stay proximal to its original behavior with a slight adjustment. Yeah, sorry if that was a little too.
Thank you for that
Yeah.
explanation. I mean, I think it just goes to speak about the complexity of these underlying technologies and approaches that are being used. It's like the end result feels like magic, but there's a lot going on under the hood. I think that's my take on this. So the topic of sentiment, how do you create positive versus negative sentiment? And I guess what this is really talking about is, when we think about these models and we think about machine learning, how does it know the difference? What does that even mean?
Mm-hmm. So this goes back to something that we were talking about in, like, I guess, what do you call it, the back room, like while the talk was going on. This is a lot of simplifications had to happen to make this Mini-ChatGPT work. And by the way, this is taken from I'll say this again, and I said it before, it's taken from Leandro von Wera's GitHub repository, which is from Hugging Face and from OpenAI. I want to be very transparent that, like, I didn't do this all myself. I don't want to give proper credit to the proper people where credit's deserved. But a lot of simplifications were made. For ChatGPT, what they had a bunch of data where there were instructions and then answers to those instructions, because that's what you're doing on the OpenAI interface, is you're telling it to do something for you or to write something for you, and it does a good job of it, or usually a good job of it or a bad job of it, and that's the reward. That's a very complicated task, across like instructions and answering. And so in order to put that into a toy model, instead of instructions, we're putting the beginning of a sentence that's incomplete, and then instead of the answer, we're having it do something simpler, which is just complete the sentence. But the definition of good in our case for the Mini-ChatGPT means the sentiment is positive, whereas in ChatGPT's case, the meaning of good means it's a really good, like, thoughtful answer that is non-toxic and safe, but also helpful to this instruction. And so those are the simplification. That's like sort of the simplification that you need to allow me to, like, explain the mechanics in this mini version. But the way it was trained is there's a lot of, prior to ChatGPT, there's already a lot of data out there. This one uses the IMDb data set where people are, like, scoring, like, on a, 1 star means I don't like this movie, to, like, 5 stars means I really like this movie. And they have these star ratings along with like what they wrote. Like, this is a boring movie. It's, like, formulaic, and, like, I've seen it 1,000 times already in different forms. And that's an example of a bad review. And then other ones are saying, although it tends to be repetitive, the CGI is amazing, and, like, it's worth it just for the visual effects on its own. Like, so that's an example of a positive review. And so they were able to correlate this reward, the number of stars, with what was actually written in natural language. And so a reward model that's different from the policy is trained just to assign, like, just to assign points to writing. This sounds like something that's positive, this sounds like something that's negative, and that's all it took to train a reward model.
Yeah, I think this whole topic is really fascinating, because when we talk about things like sentiment, at the end of the day, this is all patterns. Like, what makes, when you look at, even as a human being, you look at a phrase and it's like, why do you get a good feeling or a bad feeling? It's because your brain is picking up patterns on the kinds of words that were used. And it's like, at the end of the day, when machines start doing that, they don't have emotion. They just know patterns, and they know that, oh, I've been taught when I see this pattern, that means this. And I've been taught when I see this pattern, that means that. It's really fascinating.
Yep.
Next question. You said that ChatGPT's data set is a large collection of instructions. I thought ChatGPT started ChatGPT. Oh man, they need a name that flows better. Can we just, like, abbreviate it, like CG or whatever? I thought it started with a huge data set of words. What's the difference between, like, words and a collection of instructions?
That's just a really good question, Glenn. So at least in my talk and the way that I will use the words, I'll separate pre-training from reinforcement learning. So all these models, they don't start off with randomized parameters at the beginning of their training. They started off first with a model that had already been pre-trained. And when I say pre-trained, I mean, like I talk about this in my talk where first it learns, it's not learning how to write proper grammar, for example, at the time of reinforcement learning. It comes into that part of the training already knowing how to speak in proper grammar, and to how to compose words correctly. What it hasn't learned yet is how to answer instructions in a way that's satisfying to people. What it doesn't come in to that training with is necessarily a notion of what is safe or coherent, or effective or helpful. These are kind of the more hard to encode desires that we have. That is why we came up with RLHF in the first place. But it's just completing the sequence, like an apple is the color. You know that the probability distribution is pretty much going to be centered around red and green, because apples tend to be red and green, and there's going to be a low probability mass assigned to purple or like cat or whatever. But that is how it speaks in proper grammar, because the probabilities are always going to be assigned to the next token that has grammatical sense. And reflect what it's learned in the training data. But what hasn't been encoded yet is our desires. Like you need to make it lengthy enough, and you need to be thoughtful about it. You need to refer back to the instructions that I gave you. So that's the reinforcement learning part. But the reinforcement learning part, if you read the InstructGPT paper, they call it supervised fine tuning. That's actually three parts. There's like, I trained it on all the internet. I just learned proper grammar, and then I trained it on like a more specialized version that has instructions, so it has more of an instructee, answery kind of a feel to it. And then I trained you on a reward model with reinforcement learning to like really make you do it in a way that's satisfying to people, because there's more than one way to answer a question correctly, right? And there's more than one way to pose a question. There's more than one way to answer a question, and there's more than one way to answer a question well, and there's more than one way to answer a question poorly, which is why the supervised fine tuning is. I mean, this might be the reason why, but maybe that's why supervised fine tuning doesn't really get you all the way there, and you have to do this reinforcement learning to just let it generate on its own, and then just give it rewards.
Okay.
Yeah.
We've got time for one last very quick question, quick answer. How much does the negativity or positiveness of the query to ChatGPT impact the negativity or positiveness of ChatGPT's response? Like, are we leading it?
That's a good question. I think, I haven't tried this too many times. I haven't done a rigorous study of this on my own. So if you implement if you get cloned the repository, you should try this experiment. It'd be a really great thing to do to like really make sure you've learned it well. I suspect that if you give it a sentence that starts off very negative, and it knows it's trying to make it better, it'll just have to do its best. It'll be like, this movie is quite formulaic. Like in my previous example, if you started like, this movie is pretty boring, and then you let the Mini-ChatGPT continue, it'll probably say like, however, right? However, towards the end, it pulls it together and like surprised me in ways that I didn't anticipate in the beginning. Something like that. I'm just making this up, but like it should, if done correctly, try to recover, because it knows that its job is to create positive sentiment. But I'm sure you've given it a harder job by starting it off that way. But you should try it yourself. Yeah, I hope it works well. Yeah.
Thank you so much, Carson.
Yeah, maybe we can all challenge ChatGPT with that. And we have a couple answers to your question, Glenn. We have, for easier names, Chatty or Clippy20. But thank you both for this. And let me now introduce our fourth and final speaker, Jun Ling. Pleasure to introduce her and give a talk about the science behind ChatGPTs. We're going to take this back out of the code and the math up to a higher level of the science behind this that makes ChatGPT possible. She's the ideal person for this topic. She's had a long career in data mining and leadership positions at Bosch Research, at eBay, at PayPal, Samsung, all leadership in data mining. And Jun Ling also is the chair of AI Frontiers. And that's an organization that builds communities of data scientists, data engineers, AI researchers, and educators with the aim towards showcasing deep learning research in large-scale applications. So Jun Ling, bring it to home with us. Bring it home for us, please.
Hi everyone, my name is Junling Hu. I'm the founder of Coach.ai. Today I want to share the topic on the science behind the ChatGPT. So let me first share my slides. So everyone is very excited about the ChatGPT, and probably all of you have already tested the different function of ChatGPT. And it looks almost like magic for people who don't study AI or who are outside this field. So today, first, I would like to demystify this technology for all of you. I have been working in this field for more than 20 years. So I just want to try to use some plain language so that everyone can understand what is exactly ChatGPT. So first, to give a high-level overview for ChatGPT is you can think about ChatGPT is essentially a deep neural network, and this neural network has input. And let me actually explain a little more what we mean by a deep neural network. So a deep neural network essentially is a big function. So all of you who study computer programming, you give a computer program input and you get output. So in a neural network, essentially is an algorithm that has many functions inside. It has an input layer and it has an output layer. In between, there are many hidden layers. When we say deep neural network, we always refer to the case where there are many hidden layers. So here, for this neural network, the important part is the neurons. The neurons are the representing what the computer perceives, and the output is what the outcome it generates. So for ChatGPT case, the input would be each node would represent a token, or you can say a subset of the token. Then the output is the word it generates. That is a high-level view. And a neural network can also be applied to other situations, like we want to use this to classify a disease. So the input could be the blood pressure, the glucose level, the weight, and other numerical information. And the output could be 4 different types of disease. So in this case, the second disease, 0.6, has 0.6 probability. So it could be this person has a heart condition. So this is a very high level general understanding about the neural network. And one of the important part in the neural network is the weights. So here the weight is show the 1, 2 weights, and all these links are the weights. Essentially, what we are learning, what ChatGPT is learning, is those important weights. So those determine what output will come out. In the case of ChatGPT, the output layer has more than 30,000 tokens, each corresponding to one of the words it generates. So when the ChatGPT takes the input a user sequence of words, it will generate the select one word first, generate that word, and then generate the second word. So it generates a word one by one. So that is how, in a high level, how the ChatGPT works. Now, in the more specific level, if we want to understand the architecture of ChatGPT, is that it's based on so-called transformer architecture. The transformer architecture is a special type of neural network. It first is feed forward, meaning it goes from input to the output. In certain other type of neural network, for example, the recurrent neural network, the arrow can go from the input and back to itself, to the hidden layer. The same hidden layer can go back to itself. So that's why it's called recurrent. So in our case, the network direction is very simple. And then in this neural network, we have two types of layers. One is called the encoder layer, another is called the decoder layer. The encoder layer encodes the input, and the decoder layer take what's coming out from input or from the encoder, then generate output. So on the left, you can see this is a standard view as I showed earlier. But on the right, it's the same neural network, but it rotated 90 degrees. So the input is at the bottom and the output is at the top. And this makes it easier to describe the neural network if we want to have more layers to show in a paper. So this is just a convention where people nowadays show the neural network from bottom to top. You can imagine that is exactly like the same picture on the lower left corner. So what is inside the encoder and the decoder layers? In the encoder layer, we have two sublayers. One is the first sublayer is called the attention layer, and the second sublayer is called the feed-forward layer. The attention layer is the core technology for transformer, and it actually started the NLP revolution. Because before that, it's very hard to capture the sequential information inside the language input. So by using attention, we actually can attend to the word before the current word, so that we can capture the sequential information. And the second layer, feed-forward layer, is a standard layer, as I showed earlier, just a layer of neurons that has connection with the previous layer. So this part is very straightforward. For the decoder layer, it has one actual layer in the middle. It's called the encoder-decoder attention. It attends to the previous attention layer, and also take the output from encoder as one of the input. So this is what we know inside each encoder and the decoder layer. But for simplicity, today's GPT and many other large language model only use decoder layer. The early days back in 2018, 2019, people still use encoder like a bird, but it's purely based on encoder. However, if you want to generate words and actually generate specific language tokens, it's better. We have to have decoder. So decoder is an essential part of generating text. The encoder part is mainly for classification. Now, in the decoder layer, what we would like to look is so-called GPT, because ChatGPT essentially is based on the first GPT model. The GPT stands for Generative Pre-training. And here, generative basically refers to the output of this model is a text token. That's called generative. Now, the token could be corresponding to one of the words in the dictionary, or it could also be a neuron, a symbol like 1 or 0 that indicate a classification task. So as you can see, the first version of GPT has 12 stacked layer, identical layer stacked on top of each other. And inside each decode layer, we have we call masked multi self-attention. Essentially, it's attention layer, but the word only attends to the word happened before, not after. So it's one directional. That's why it's called a mask. You mask the remaining word it hasn't seen before. The second feed forward is the same. And then you can see there's a plus sign where it goes from the input to the output after the attention. So after you transform through attention layer, then you add the original input back to the output. The reason we do this, this architecture is called a residual network. The reason we capture the residual is that it helps us to actually to get the original input and not let it lose over time. This helps us to do back propagation in the neural network. So for neural network, when we update the weights, we back propagate from the final, the last layer, all the way to the first layer. In doing so, we take a derivative. Essentially, the back propagation is based on the derivative of each layer, the function of each layer. If we don't add the input from the previous layer, after many transformation, the function transformation, what's remaining to be updated in the beginning layer will be very small. And we call this a vanishing gradient. So it's very hard to update the neural network. By keep the original input add back to the output, we can get a derivative. At least there is a one unit derivative from the original input. So we can we don't have a very small number there. So that is the residual network reason why we use that. For now, we have for this decoder, it has 100 million parameters. And we can see this is already very big for that time. But it actually not that big today in today's standard. And one thing I want to mention in the GPT model is this so-called layer normalization. It is a transformation of each layer to normalize it based on the current layers, the aggregated sum of current layers. So you get you convert the number between 0 and 1. So that's a normalization. It helps the convergence faster. Now, when we talk about representation of words, how do we convert a natural language to send it to a neural network? It's easier to understand that the neuron takes some numerical numbers and then we do numerical operation on the neurons. But what if it's a word? How does a neuron, what number do we give to the neuron? A simple way, very simplistic way, is to convert each neuron into an index of the word. So if the word is index 99, the first neuron should have the value 99. However, this would create some bias because yes, our input can have, say, 30,000 neurons, each corresponding to one word, but their numerical value could create a problem. Some numerical value are much larger than the other. So in order to make all the neurons equivalent, have the similar weights, we actually make each neuron, we convert a word into a vector. So in this vector, we only look at the position that's corresponding to the index of the word. And for that position, the numerical value is 1, the rest is 0. So we call this vector representation called one-hot vector, one-hot representation. As you can see, this vector size totally depends on our vocabulary. So if we have 50,000 unique words, our vector size should be 50,000. And as you can imagine, it's a very big vector. If we have many words, the computer requires a lot of memory to remember each, to basically waste a lot of space to memorize each different word. So instead of using such a one-hot representation, people come up with another representation of word, which is a much smaller vector. So this vector could be only maybe 200 or 300 wide, only 300 elements in the vector. And this vector actually can capture the information about that word. So that is kind of very interesting. What people find that this is essentially mapping a word to a hidden space where you can have much more compact representation of a word. So what we discovered that once we map the word to a smaller space, in fact, we can actually discover the relationship between words. So for example, here, fight has a longer distance to love than to kill. And the people also discovered like London is very close to Paris, then London to like a general word like Monday. So, and then you can also do word operation in this hidden space. For example, the king of British, the king of England is similar to the king of France. And when you do the like minus or plus operation after they each operate of each other, then the actual distance is very similar. And so people find this interesting mapping, and this allows us to capture the relationship between words. So we call this dense representation. It's a dense vector because it's smaller. We call it a word embedding. And that is give us the understanding about what goes into GPT-3. And the same thing, we also want to encode the sequence of words. So the way we encode that is using position. Now, how do we send this position to the neural network without like a bias 1, 2, 3, 4 using the numerical value? So we do the same thing. We convert that into a one-hot. We convert it into a small vector, and that size of that vector is the same as the word embedding. So as you can see that we can then add the word in vector with the position vector. And essentially they are called the text embedding and the position embedding. When we add them up, we send the outcome, the sum, as an input to the GPT. So that gives an overview, essentially from NLP viewpoint, how we represent words. And you can see GPT-2 has a little slight different architecture from GPT. In GPT, the layer normalization happens after each main sublayer, like attention and feed forward. In GPT-2, they do layer normalization before, and basically it's normalize the values. And the rest is the same. And of course, GPT-2 is larger. It's twice larger. Then we go, by the time they invented GPT-3, it becomes significantly larger than GPT-2. In GPT-3, the architecture stays the same as the GPT-2. And now the major difference of this GPT, not only they become larger, and also they requires much more training data. For the first GPT, you only use 7,000 books. The GPT-2, we use the 80 million documents, 40 gigabytes of text, and all crawled from the internet. And they cleaned them up themselves. In the GPT-3, we have way more data. As you can see, not only the web text is a newer version, we have more books. We added Wikipedia. We now have a much, much larger web document called Common Crawl. Common Crawl has 410 billion tokens. It's the largest data set among all the data set. So that's the power where the power of GPT-3 came from. And I want to give you this high-level timeline to understand the development of ChatGPT. And as you can see, Transformer happened in 2017, GPT happened in 2014, then GPT-2 2019, the GPT-3 2020. After that, in 2021, they applied the GPT-3 to GitHub code. So they trained on all the GitHub code to allow the model to generate code, programming code. So if you train on Python, it can do Python programming, it can do C++ programming, and the instruction essentially is the human instruction in those GitHub code. And then there is another thread of development which contributed to the ChatGPT success. So even though GPT came out in 2020, and then OpenAI released the API in end of 2021, it hasn't generated much buzz because the public doesn't, there are two reasons. One is the public doesn't know how to talk to GPT-3, which is in the backend. Second is the accuracy and the usability of GPT-3 is not that ideal. So in comes a new method that is using reinforcement learning to improve GPT-3, and that achieved a very good performance, and that's called the InstructGPT. So in order to understand InstructGPT, we have to understand the basic of reinforcement learning framework. So in the reinforcement learning framework, we have three things to worry about. One is the state, what is the current situation. Another is action, what I can do. The third is reward, how the system reward me. And the agent is trying to optimize, maximize the total discounted reward. So based on this, we can build a neural network, try to learn what to do in every situation. In our case, the policy network, we call this a policy network. Essentially, in our case, we are trying to learn how to generate a word based on all the inputs, the sequence of words. So our state is the sequence of words. Output is one single word. And the GPT basically generates a word one by one after one another. Each time it only generates one single word. So it selects action. Its action is one of like 50,000 possible actions it can take. So for InstructGPT, I want to talk about this main step. The first step is get a human to label, to generate some answers. So this is purely human-generated data. We feed this data to the GPT-3 to continue to train the GPT-3. This is called supervised learning. In the second step, we allow user, let GPT generate several answers and let a user to rank the answer from good to worst. Then that's a numerical reward. We use that numbers, the corresponding ranking numbers, or some numerical number to represent the ranking, and feed that as a reward to build a reward model. In the third step, once we have that, we can also optimize, use this reward to train a policy function to tell the GPT what to generate. This reward, this policy function essentially is our InstructGPT model. And this model, for this reward, the policy function, the input is all the users' prompt plus examples plus the questions, and the output is the tokens. So it generates repeatedly until the user, until it reaches the end of a token symbol, so it doesn't generate anymore. And as you can see, InstructGPT significantly outperform GPT with even a small size, 6 billion parameter. It performs better than the original 175 billion GPT-3 model. So it's very exciting. And finally, the ChatGPT is built on top of InstructGPT. with some additional dialogue data. That the dialogue data are designed by the humans. So that is my major talk about the science behind the ChatGPT. Finally, I just want to talk about my company, Coach.ai, and you can go check it out. And if you have any question, I'm going to skip the illustration of our technology. But if you have any question, you can reach out to me at Junling at Coach.ai. Thank you. Bye-bye.
So Jun Ling, thank you for that really thoughtful, thorough sort of overview of all the things behind ChatGPT. Kasaba Top, who's in our stream, asks a question about the encoder and that wasn't used even in the training phase. Can you expand a little on, or do you know why OpenAI didn't use the encoder?
Yes, so encoder is useful for transform the input to create an internal representation embedding, then send that to the decoder to generate. But to train the data, encoder itself does not give you feedback on whether the data is correct or not. So we have to generate the output to go all the way back to the input. In order to get a feedback from the data, so decoder is the most essential part. So by removing encoder, the training can be faster and then take advantage of all the decoder side. And that's why OpenAI did not use decoder. In fact, Google also moved toward the decoder only architecture. They actually moved away from original BERT. BERT is the encoder, pure encoder architecture, but now Palm in Google is all using just decoder. So this is the trend that people only use decoder now.
Okay, thank you. You talked about data sets. ChatGPT was trained on web text 2, books, Common Crawl, Wikipedia. A couple things. What is Common Crawl? I hadn't heard of that before. And are these data sets publicly available? Are they available in multiple languages? Could you talk about that some?
Yeah, so all of these data sets are public available. Common Crawl, you can go to commoncrawl.org. It's a public data set anyone can use, and they also ask people to donate. The most data set, all of them are in English, but because the web page has multilingual, like Wikipedia has probably other languages, it can contain other languages, but majority is in English.
Oh, so is that true then? ChatGPT, and the earlier one we're struggling with an easier way to say that name, like Flippy 2. So ChatGPT is English only. There isn't a Spanish version or a French version, because I know it does translations.
Yes. So the way it translations is still through the web page. We use web text. So in the web text, if you have a document, say if you tag every English word and it has a parenthesis, a French word, then it automatically learns they're associated. Those words are associated together. And then you can also give instruction inside the original documents indicate that these two are corresponding to each other. For example, in the Canadian website, they have both French and English. And in some other websites, they have English and other language. So they learned automatically through the same route how different languages are corresponding to each other. But there's no specific language for them to learn. In general, they just trained all type of documents on the internet, however many language are there. So that's their, so it's English main focus, but somehow they learned other language. This actually is described in described in GPT-2 paper. So why it suddenly was able to detect the multiple language in mainly English corpus. Yeah.
I'm fascinated by the word embedding that you talk about, the hidden space, and the dense representation. Can you describe that a little bit more? Like, have these dense representations of words been around for a long time? I take it that there's only one for English, because there isn't one like one for French or Spanish. Is that the case?
It's one for any language, for any word. So whether it's English, Spanish, Chinese, Japanese, every character, a main word can be mapped to a vector. So that is the theme. That's how computer can recognize and then process the word we speak in human language. Computer only knows numbers, 0, 1, and maybe floating numbers. That's what a computer knows. So we converted the word into a vector of numbers. Now, when we say dense vector, this vector is very small and it doesn't have many zeros. It mostly contains non-zero numbers, so it's dense. The size of the vector, it's really arbitrary. Actually, we can pick the size. Original bird is 256, then people expanded to 512. Now we can do twice amount. It's really our computing power. So we decide how large this vector is. When we say hidden space, essentially is meaning when we represent the word in the dense format, small vector, somehow we can discover the relationship, but it's not randomly discovered. We discover that by use pre-training, by going train the network, train this neural network through the many web texts to understand how the first word predict next word, the first sentence predict next sentence. After that, those hidden space, those word embedding, then can tell us relationship between words.
Fascinating. Centaur L asks, what are the options if one wants to train ChatGPT on my own training data instead of the data that's available on the web?
Very good question. Right now, what the option they offer is you can upload your data set to OpenAI, and then they will train for you on their web, on their infrastructure. But they haven't open sourced the ChatGPT, the last GPT-3 model. So we don't know what the model look like. We don't have the parameters. That's still a secret of OpenAI. If you need to build your own similar open source ChatGPT, you probably need to download from Hugging Face, get some current like GPT-2 model or OPT model from Facebook, or T5 model from Google. So you can get some open source model, then follow the InstructGPT methodology, do some reinforcement learning on top of that, and then you can create something similar to ChatGPT.
Right, doesn't sound easy, but sounds possible.
Yeah.
Do you have from your talk some good online resources if someone wants to learn more about the concepts? Roper is asking us this question. Online resources for the things that you talked about in your presentation.
I would recommend read the 3GPT paper, the one from 2018, the original GPT paper. Those are listed in my talk. The GPT-2, GPT-3, and then last paper is InstructGPT. In terms of explaining, I think it's so new. ChatGPT just came out end of November 30. So it's only like 2 months. And I don't know if anyone have written materials. Maybe I'm thinking about writing the instruction material for that. Maybe there's some online talks. I also have another talk on a much deeper about ChatGPT. So I think that's all we have. I would just encourage you to watch the video I just gave and on the major timeline, the major papers I mentioned. So I think that's the best way to go about learning about this.
Okay, thank you. I'm going to ask about InstructGPT. You mentioned that GPT-3 generates one word at a time like ChatGPT, but it was difficult to use, and that you said InstructGPT made it significantly better. Can you explain what InstructGPT did to improve GPT-3?
So GPT generate one word at a time. InstructGPT also is the same. InstructGPT is still the GPT-3 model, but add on top of that with reinforcement learning feedback to make the model better. So it's for every decoder model, every GPT model, they only generate one token at a time. That's including ChatGPT. what InstructGPT does is what previous speaker Carson also mentioned, and I mentioned at the end, is a reinforcement learning methodology to instruct the model to behave better. So the way they do through 3 steps. The first step is supervised learning by human to write a question answer, almost like a human act like ChatGPT, write some question and then generate some answers. So this can be a supervised training material to update the GPT-3 model. After that, then they train a reward model. The second step is reward model, where you let the GPT generate 2 different answers, and the human label which one is better. The better one get higher reward. And the last step is a reinforcement learning model, where the reinforcement learning essentially is the GPT-3 model itself. The input is the sequence of words. That's a state. Output is action. Action is one of the words you should choose. Essentially, when we have 30,000 action, is the total. If the total number of vocabulary is 30,000, so that's how they choose the best action. And so this 3 step is InstructGPT.
Okay. Are there any sort of innovations in algorithms or machine learning that you see in ChatGPT-3 that you find most impressive? What has OpenAI done that's most impressed you?
I think the major innovation from OpenAI itself is the reinforcement learning. That's originally invented in OpenAI. A year before that, they used reinforcement learning to improve book summarization. So when book summary used to be difficult, the summary is not accurate when the document is very long. So they introduced this human RL, reinforcement learning, HF, human feedback. With this methodology, they see a dramatic improvement. So the same author worked on GPT-3 and wrote the paper InstructGPT, and that's a breakthrough. Now, before that, the major technology is transformer. We know transformer was invented in Google, but GPT also is the first one come use a large online document to do pre-training. So this is the innovation, the pre-training part. People understand the pre-training, but the first time we use a very large online document to do pre-training. And the essential power comes from the model size. So GPT-2 is only 1.5 billion, GPT-3 is 175 billion. So it's 100 times more than the previous model. Secondly, the data also 100 times larger than previous data. So the main power comes from the data size and the model size.
Do you know, are they continuously feeding it new data, or is it now reached a static level?
For each model, you train only once and use that later by adding more prompt, other information. If they want to train GPT-4, they probably collect additional more data. There are more text data they can collect. There are even more books, more manuals. There are many more data you can add, but they trained once. It's not like they train every day. They cannot afford that.
Okay, we have another question on the chat. So we're talking about the special power between ChatGPT, and one is the RLHF, the human factor in machine learning. The other one is the PPO, which was the, oh gosh, can you remember that algorithm, what that stood for?
So
proximal policy optimization. Yeah, is that an innovation that's in ChatGPT-3, or is that something that's been around in AI?
Yeah, PPO was invented in OpenAI too, back in 2017. So PPO is also a unique technology for doing reinforcement learning, and the author published through when he was at OpenAI. So it's a special way to update the policy network that I mentioned, with a reward that's bounded by certain range. So that's proximal. The reason is you don't want the reward to be too high or too low to disrupt the current learning. So that's the essential idea of PPO. But they do have mathematical to prove, to show that what kind of bound it actually should set. And that's the PPO idea, and then they gave a formula how you should update your reward, your policy based on the reward.
All right. Well, Junling, thank you so much, and thank everyone else who's joined us. And I'll turn this over to Peter to wrap us up and take us home.
Thank you.
All right. Well, thank you, Tammy, for being such a great moderator, and Junling for a good last session. And certainly want to thank all the speakers. This is all like volunteer Saturday morning stuff where everybody has other things to do on Saturday. So let me take over the screen, and I'm going to tell you in a minute a little bit about the format. There were a bunch of questions that came up. So one thing that was sort of interesting, people wanted to know what was live and what was not live. So I thought I was transparent about this, is the sessions were all recorded, the 25-minute sessions, and then the Q&A was actually live. And the reason we did it this way is if you think about how online works, you don't really interact anyway when you're online. So there's really not a lot of point in having a one-way conversation not recorded, because then the speaker can really think about it and get it right. One of the other side benefits is we just have a lot of fun talking in the Zoom meeting while you guys are watching the session. So personally, I guess it's a little selfish, but we just have a great time. And I don't know if anyone noticed, but after the second presentation, the transition back to the Zoom meeting was a little slow, because I looked over and the screen was black, and I was like, oh my God, I forgot to transition. So hopefully that wasn't too bad. So anyway, so basically that's the format. All the sessions are recorded. Even my intro, I recorded that last night outside, even though it looked like a fake background. It wasn't. That really is our backyard here in Borrego Springs. So some logistics for the sessions online. I'm going to immediately publish 3 of the sessions. The last 3 sessions, they're all recorded. They're unlisted on YouTube right now, and I'm just going to turn them to publish. So you'll see them in like 15 minutes. We had a lot of feedback on Glenn's first session, in that people couldn't read the slides very well, because Glenn of course sent me the 1080p versions of his slides, and I crunched them down to fit in the upper right, and so you could see his picture in the lower left, and that made it a little difficult to read. So I'm going to spend an hour or so re-edit that video, republish it, and then uploading from here in the desert, even though we have this great infrastructure, it's going to probably take 2 or 3 hours to send it up to YouTube, the 5 gigabyte file it creates. So Glenn's probably won't be visible till tonight. And then all this Q&A that we've done, I'm going to package that all up too, and I'll publish that over the next few days. So basically that's it. Thank you everybody for coming. I had a great time. I know our speakers in the back chats were all talking about how much fun it is. I'm sure we'll do this again in the not too distant future. There's a lot more to talk about with ChatGPT, and we'll be here talking about it. Thanks again for coming.